Okay, good morning. Good morning, everybody. Great to see you. We welcome you here to the University of Applied Science, Burgenland. We're happy to have you here. We're happy to have PyCon for the second time. Everybody knows Horst Jens. He's the main organizer, so to say, and the main organizer concerning the building and the university. I give you some introduction to those who don't know where we are. We are the Hochschule Burgenland, the University of Applied Science, as I mentioned. We have quite some onion rings of organizations around us. We're running two locations, one you just visited here in Eisenstadt, one in Pinkerfeld. This is the numbers, the number crunching, so we quite have some employees, business partners, lecturers, quite some number of bachelor's degrees and master degrees, and quite a number with 3 zeros behind of people studying with us. So we are happy to have that. We combine, we have study programs, lecture programs in various fields. This is, you're just visiting the IT department, so to say, but we also have business, information technology, I was just mentioning, energy and environment, health, and continuing education programs that we are running. Concerning, I don't introduce the others, I just introduce ours, the information technology department I'm working for. We have several bachelor and master degree programs you can read about, but what you will more be interested in, so what do we teach about programming? Our approach is to teach actually many programming languages to let our students to use the right language for the right task. But as you're particularly interested in Python, you teach all of them somehow, somewhere in the lecture programs. But in particular in our relatively new, now running for the second year program, Bachelor Business Informatics, we have chosen to teach Python as the basic language, so the first mother tongue language in programming in our first semester of this bachelor thesis. Actually, Horst Jens is one of the two Python teachers that teach our students. We're proud about that. So we have quite some partner universities all over Europe and even abroad, and quite some, a big number of industry partners. And concerning IT, we are proud that we are running the Linux Weeks Eisenstadt now as the longest running event in Austria concerning this topic. We started in 2003, and without interruption, even not with COVID, we're running this little conference, which goes on today. We just declared the German-speaking track that happens in Hörsalfir to be the second day of Linux Weeks and equally the first day of Python. So we have a German-speaking track also, which is running in Hörsalfir. Yeah, and concerning that, let me just introduce, and that's why we always look for teachers. So actually I would like to have me 4 times, me also I wouldn't have that much work. So we're particularly hiring IT teachers. If you know someone who likes to teach, who's really deeply into technique, so we particularly seek the teaching nerds, so to say, the guys or girls or whatever, that love to dig into the details and love to do programming, that do not run away from math, where something that sounds like it's too technical just doesn't exist. So these are the kind of people we are searching in our lecture programs. We have others too, as you see, but we have plenty of them. We particularly seek for the teaching nerds, like currently now. Yeah, and if you happen to want to study, I think the applications is still unofficially open. Don't hesitate to study with us, even right now on. Vielleicht magst du was sagen zu Python and PyCon. So why do we hold the conference? Why is this happening here?
Yes, I'm happy we can have this PyCon here. This is due to the generosity of the University of Applied Science Burgenland, who gave us this venue, the rooms and the infrastructure for free. Actually, they gave them to Linux Wochen, and then they said, let's just expand it. And so you're in one of the very few international cons, also Python conferences without entry fee. The flip side is that this is all on a shoestring budget organized by two guys, Thomas and me. So if some of you don't have a name tag, look at me, I also don't have one. The reason is very simply, at the time I printed, I had 180 registered visitors, and then at the time I was in the print shop, I had over 200, so some people got kicked out and are now left nameless. I hope you have enough social skills to introduce your names verbally. Hopefully we will have normal stickers and with pen and can make some emergency stickers.
Okay, so you see they are organizing these conferences on a shoestring budget and with really high personal effort. So we really have to thank them that this has happened, this conference is happening. Thank you. This year we also have the honor of having our dean of that's the main person responsible for academic quality with us. That will hold us an official opening, so we're proud and honored by that. Thank you, Bettina Schauer-Frank, our dean.
Thank you, Robert.
Does it work?
I'm not sure. Does it work? No.
Does it work? No.
But it doesn't matter, I don't need it. I mean, we have many international people, but not so many here, so it works. And yeah, a very warm welcome from my side to the University of Applied Sciences, or Hochschule Burgenland as it is in German. Does it work now? No. No worries. We're happy to see so many of you here and also behind the screens. I hope everything works now. And we are proud to host the PyCon Austria for the second time now. And it seems to be still a very quiet and beautiful Sunday morning, but there's a lot of things going on at the Hochschule Burgenland at the moment. As Robert just mentioned, as you probably all know, the Linux Wochen Eisenstadt with their long tradition started yesterday. PyCon starts today. On Friday we held the European Business Forum. On Monday we'll start the International Staff Week. And yesterday we had the graduation in Schloss Esterhazy, which is a really beautiful place for a graduation, just a few kilometers up the road. So if you find time to wander a little bit around in Eisenstadt, visit Schloss Esterhazy, you can't miss it. And about 400 students received their degrees yesterday. So a lot of going on, a lot of things going on in various different disciplines. And as Robert just mentioned, we are looking for teachers in IT. We're also looking for students in IT. And apart from the valuable contents that we provide in our study programs, the graduation party in Schloss Esterhazy is also a reason to study here. I would recommend. Okay, so I know the PyCon in Austria it's only the second event like this. There are other international PyCons which might be bigger events, but I guess this event here gives you the opportunity for learning, for networking, for also meeting international Python fans, and it also makes it maybe more beginner friendly if it's a rather small event. I wish you 2 productive days with Python, many interesting tracks, talks and workshops, and most of all, a fun conference party tonight. Enjoy.
Thanks a lot. We really feel honored for this official opening. Now get to the information that haven't been here yet. We tell you how you find your way. You may have obviously have found the entrance. In the first floor, in the ground floor, we have only 2 interesting points. We have our cafeteria here, which hosts our lunch and evening get together, and also breakfast. I will mention that later. And if you can afford time, on Monday our famous library has opened. So if you have a break in between, just go there. They're informed that they want to that they let you show around. Just give it a look. It's famous. It's great. And there's also, if you need snacks, it's here. Then in first floor, it's my office. If you're looking for me, if I'm not around, it's here. And there's also IT support. IT support guy is just with us because I've mentioned that later. The reason for that. And the conference takes fully place on the second floor. You have the row of Hörsaal, of lecture halls here. It's numbered from, this one is number 1, 2, 3, 4, 5. We have some additional rooms all over this aisle of the building, and we have a reception and wardrobe here. You may have already seen that, and our famous sponsor tables around here. However, on Sunday it's not very crowded. When you need an empty room just to make some private conference or private education, on Sunday you can take any room that's free. But on Monday we're just busy, so we reserved these rooms for private sessions, and we reserved the separate room for quiet working. Please stick to that. Concerning and I want to mention that the hostel is open for many of us. I think many have booked the rooms there, and this is not ordinary. It's a special service for us. Normally they close on Sunday because there's no studies going on. And for us extra, they have opened up, so I think we could really be thankful that they established a special service to hold the conference and hold the conference together, such we don't have to go to hotels in Eisenstadt. We give them a warm applause. And additionally, also our canteen offered extra service. Normally they're closed on Sundays and even restricted on Mondays. For us, they not opened up for lunch, but established a special service over the whole day. So some of us already had breakfast. That's another breakfast tomorrow. In between they're opening, this is the main point, to get coffee and snacks and sweets and everything. Then there's lunch. Please, just to feed the masses quickly, we established the rule that between 12 and 1, only those people having a voucher, such a your
little
prepaid,
pink or green card,
your lunch are served, such that they are not delayed with getting money. But if you don't have, you can even eat from between 1 and 2. So please, between 12 and 1, go only there if you only want voucher. Otherwise, eat a little later, please, so we can feed all the people through. In between, there's again conference next, and then starting from 6 o'clock, they're hosting our evening party get-together, how I want to call it. And I think it's a really special service that demands a big thank you, such that actually 3 organizations now host this conference more or less together to get you all to this nice and closed and area and service points. So let's thank our Gästehäuser Burgenland for doing that. Yeah, there are even some coffee automata here around. You will find them. And this guy is here because we have a problem with that one. So even if you find the sheets of the information sheets, it's not valid. Yesterday it worked, but we could call IT support, who was here in half an hour, to establish an alternative solution. Please meet that guy. He's going to give you a temporary password. And bist du am Vormittag noch da? Yeah. And he will be here around or even in his office this morning for us. Yeah.
Eduram is working usually?
Yeah, Eduram is working, but Open Campus WLAN gave up during the night. But we had support, and we're going to have an. Do you want to talk about what you just get a password?
Yeah, I will just assign a few guest accounts. I will probably print some of them out and scatter them around the lecture halls. So anybody who needs
you see, we have Thanks a lot. So you see, we had quite some problems, but we found solutions fast. That's what our students learn from us. I always tell them. So now please enjoy PyCon.
Wait a minute. Some announcements.
Yeah, there's some additional announcement. Yeah.
Okay, some technical announcements. Please, as Robert already told, if you intend to eat today and tomorrow lunch, please buy these little whooshers, these pink or green cards from us. They are prepaid. If we don't sell all of them, we make a loss, and this loss I have to pay personally, so I'm very motivated to sell them to you. Each meal is 10 euro. We have on the homepage the menu. And the other thing is, we have still party wristbands left for the evening party tonight, starting at 6 or 7 o'clock. And if you can always go there, but if you have such a blue wristband, then you have the same privilege as our honored speakers. That means you have a free all-you-can-eat, all-you-can-drink buffet, and don't pay extra for every consumption. Another announcement, we sell these very beautiful t-shirts that actually Ivana, the lady from the Sentry table, designed. And you can sell them at two very young students of mine who run around here. This is Anna and Lucas, a blonde guy and a girl with long brown hair. And they sell them for you for like 20 for a donation of minimum 20 euro. Yeah. The problem is only our minimum size that we have left is large. So if you're smaller, then buy them and give them to a bigger friend.
Or use them as a skirt.
Oh, yeah. Some very spontaneous and helpful speakers like Ralf and Heim volunteered to fill our holes in the schedule with extra talks because of all these flight situations and other problems. Not every speaker who was planned could make it here. And so we have some talks, and we may be not able to in time put them online. It depends on how much time we have for the registration test. We will try to write all on this big printed out schedule that is posted on the wall near the registration desk, so just look there. I want to invite Heim for 5 minutes just to announce his talk. His talk will be today at 5 o'clock in the evening in room number 5 in parallel to the lightning talk sessions that will be here. Yeah, just come. I think it is better to advertise his talk himself.
Hello everyone, my name is Chaim, I'm coming from Tel Aviv, and my talk is aligned with my personal experience during the last half a year, plus minus, in software development using spec-driven development methodology, which is not new, but it is new the way it is implemented these days using AI, and to be more specific, using a tool ID that was developed by Amazon known as Kiro. I don't know if you heard about Kiro. Now, this is just one option. There are other tools that do the similar stuff, but this one excels compared to others for now. So this is why I'm using Kiro. And that additional talk is about developing what I call zero human companies. It wasn't just giving it a try during the last month. I already started doing what I'm talking about. Well, you see, in the past, 20 years ago, in my company, I had developers. And now that I found a structured way, using this methodology, a structured way to use AI, not just vibe coding and get something that works, but something that sustains in the long term, well, you don't need developers. I know, it sounds very bad. Sorry. You need something else.
Let's stop it here. This was a teaser. You don't need developers. If you want to know more, it's 5 o'clock, room number 5. Okay? Ralf also volunteered to make an emergency talk, and this talk is online with the title, but not with the description, but it will start very soon.
This room,
I think so.
Today, about Ada, that's a Python script that uses an external AI. You can, of course, also use a local one. And I've done some experiments with it concerning C and concerning Python.
and I give you my first impressions. I'm not able to really give you a conclusion because who can give a conclusion to AI yet? So let's see what comes out of that.
We have already heard that it was funny anecdotes to listen to,
yes.
so I can recommend it. We heard it in German and in Linux Weeks yesterday. So go ahead, have a nice conference. If something is missing, something not working, reach out at the reception table or just come to me personally if you see me somewhere running around, and have the nicest conference. Welcome and have a nice day.
Also in der Lizenz am Wochenende abläuft, finde ich speziell.
Ja, ich habe es Ihnen schon gesagt, nächstes Jahr wollen wir das nicht wieder sehen, dass Sie über Lizenzen diskutieren.
Nächstes Jahr wollen wir das Open Source Software verwenden.
Ja, ich habe nicht gesagt, so weit ist es in einer Kette. Funktioniert nicht. Was immer wir erzählen, funktioniert nicht.
Du brauchst ja explizit absolut einen Single Point of Failure.
Ja. Das ist ja den einzigen Zweck, den einzigen Zweck, der überhaupt keine technische Notwendigkeit hat. Das macht nicht nichts anderes. Also dieses eine Point, die Fehler hat man vorher auch schon gehabt, die Kette über die Donau gesprochen, die Fehler in der Transport Chain of Europe und haben uns daraus. Danke. Wi-Fi. Ja, geh zum Christian, du kriegst ein Passwort für ein also du kannst dein Temporal, du hast eh ein FH-Passwort.
Nicht für mich, sondern für die Talks-Leute.
Ja, die kriegen ein Temporal-Passwort von Christian.
Christian beim...
Das ist der mit der weinroten Jacke dort steht.
Ja.
Das ist unser IT-Support-Mensch. Der wird das gleich ausdrucken.
Lustig ist das da. Ja?
Du hast ja den Vergleich zu anderen Veranstaltungen.
Ja, voll. Ich finde dieses Kontrastprogramm immer so lustig. Ja?
Das ist schon ein Kontrast.
Ja. Also jetzt absolut nicht wertend in eine Richtung, aber einfach lustig, wenn so viele verschiedene...
And it works excellent. And you know exactly what happens, you control every step, everything that happens. In terms of the code itself, the technologies, architecture, design, in a structured way that you just watch the machines doing the job, approve, disapprove, introduce changes, and in some cases you are in kind of loop with the machines in order to get a better decision. But 99.9% is done by the machine. And there are things that you don't even check. I mean, when I see the documentation, so I take a look here and there, this is fine. I don't read all of the documentation. I have part of the documentation, that's it. When I look at it's kind of how we can work with CPA that goes over the accounting books. So it depends on the context. In some cases, you do want to go over every line. But in some cases, you say, what the heck? I mean, this is a platform for putting lines like Facebook, so you take the risk, so it depends. And you take the decision of how go into.
Depends on the gravity of the things happening.
Yeah, exactly. And actually, humans compared with machines, humans also like more, by far more. So it's kind of working with the excellent coders and.
Sometimes those are probably also a legal question to sign off on the application of set up and not deploy it.
Well,
if it's something serious going on.
Yeah, but when dealing with zero, it's about one person responsible for everything. Something that is possible today because you have AI, it wasn't possible in the past. So he's responsible for everything. So if it didn't speed up the process.
Also, er hat die Kamera, dann hat er eineinhalb oder 2 Stunden hat er Speicherkarte und er wird, aber der ist das nicht dabei. Das ist gut. Test. Installation. Nein, das ist. Also der funktioniert. Ja, Mikrofone gehen keine. Also das ist das einzige Mikrofon, das geht. Das ist okay, gut.
Du musst das hinten holen.
Aha.
Das sind markiert mit den Farben.
Ja, okay. Ja. Und der, wie schaue ich mal den an? Ah, hier drinnen, okay. Gut. So. Nimmst du das Handmikrofon oder den
Den du in die Tasche stecken kannst.
Ja.
Der ist ein bisschen blöd.
Ich hätte lieber eins, was ich einstecken kann.
Ja, und der ist da akku, ja.
Der ist
Achso,
da
okay.
jetzt.
Ja, ich. Kurzes Mikrofon. So, good morning, ladies and gentlemen. Technical session start now. I would like to introduce Ralf Schlatterbeck. He's going to talk about the Python framework Ada and how to do vibe coding with it.
Yeah, welcome to PyCon. I'm going to present some experiments I did with Ada. I'm not involved in the development of it. Instead, I used it for various experiments with my own software. And I'm going to, it's more anecdotal evidence than a full conclusion. I guess no one yet can do a full conclusion of what we can do with AI. Ada is a Python program. I had first good results just installing it into a virtual env myself with pip install Ada chat, but this did no longer work.
Sorry, I forgot to.
This works?
I think so.
I stick with that one. Because I don't even find how to turn it on now. But I have more success with Debian Trixie, which is the current Debian release. With Ada install, it just installs a new Python interpreter and works from that, because it seems that the Python version used in Debian Trixie is not working together with Ada. One, two, yeah, seems still to work. Ada can use an external AI, for example, Open Router, or it can use other AIs with their, for Open Router, you're probably aware, can use various AIs, and it also supports vendor-specific APIs like for Entropic Cloud, which I was using in these experiments. It works by starting it in your project. So you have a git checkout and start Ada in that directory where the git checkout resides. And it directly produces git commits for you. That means if you want to change anything, which you usually want to, then you should be familiar with git commands. I've become more familiar than I was before with git rebase, because you quite frequently need to, say, merge two commits that Ada did into one, change some things like coding style, things like that. Kann ich ein Wasser haben? Ist das möglich? Das wäre super. So when you start Ada, it opens a chat window in which all the interaction happens. So you give it the prompt in that window. For short prompts, that's fine. When you need longer prompts, it can call your favorite editor from within that. There is a meta command that opens the editor for longer prompts. Yeah. And what's very interesting with Ada is that you can switch between directly prompting it to make changes to your software versus discussing some architectural changes or changes you want to make
before actually doing them or without doing them, so that you can, so to speak, do a technical discussion with Ada, which is quite valuable because it can analyze your code and propose how to change this to be able to hold new changes or something like that. What also is interesting, I find that when you test an AI, many tests out there start from scratch with a new project and have the AI code something. I don't think that's a valid test, but what you usually do as a software developer is you have some existing code and want to change it. And this is a better test, in my opinion, than writing something from scratch. My first experiments date back to Claude Sonnet 3.7. So that's an older version of Claude. I think it dates back almost a year now, so that's really ancient in AI terms. And I've later experimented with Claude 4, not yet 4.1. I think currently we are at 4.7 or something. So it's an older version of Claude, and you can expect that this is an exponential growth, what the models can do for you. So typically, when you come from, say, Claude 4 to 4.1, it's not getting better some 3 or 10%, but it's getting better by 50% or something. It's difficult to measure that, but in my opinion, this is the case. Ada uses a second, weaker model for doing the non-reasoning tasks like Git commits and things like that. And I already said the test is on modifying existing software, not something you start from scratch. I don't think it's a valid experiment starting from scratch because it happens a lot less often, of course. Ada writes all the things it gets into an input history and writes all the things it produces as output to an output history. I think the chat history also contains the prompts, otherwise you wouldn't know on which prompt it did which answer. And this was used in the anecdotes I'm presenting here. Thanks a lot. Yeah. And of course, this is anecdotal evidence. I don't have a consistent picture yet. So I want to do a short caveat. If you are experimenting with AI, in my experiments, I was using open source software, which I maintain myself. So I don't have to worry that this information gets public or gets published to an AI. All these programs I'm maintaining are on GitHub anyway. So they were already used for training AIs, lots of them. So I don't have to worry that someone uses my code for whatever purposes. I wouldn't recommend doing that with proprietary software. You don't know what's done with the information you feed to the AI. The first example is a C program I'm maintaining. It's called PGA-PAC. It stands for Portable Genetic Algorithm Library or package. This was conceived a long time ago in the 1990s, and I'm maintaining this package and have added more modern algorithms to it. And I wanted to change a sorting algorithm. This is non-dominated sorting. And So that's the background. The program is written in C, but it also has Python bindings, so you can use it with Python. And in that case, I'm just adding a single file. Usually there is a meta command to add a file. It's with a leading slash. I forgot that slash in the first example, and it asks me if I want to add that file, and then summarizes what it found when reading that file, which is okay. And then in the second example at the bottom, I'm just adding another file, and this time I didn't forget the leading slash, and it just answers edit file, and also gives a summary in that case, which I omitted here. Then I'm prompting it. The idea is I'm doing a major change, and I know that the test coverage at that point for certain things I'm going to implement is not that good. So I'm trying to prompt it to first establish a baseline by writing a regression test. And then after that, once we have that test, we can be more confident with the changes we are going to make. And so it sees that what files it needs for that, and I'm using a very simplistic regression test. But I have a C program which produces an output, and I just compare that output to something that is expected output. And it has analyzed everything and now tells me it wants to see the expected output also in the file .data, and if I want to add it to the dialog. So it asks me here to give it the data file also, so that it can start modifying things. That's just to give you an idea how the interaction with Ada happens. So you give it commands, and we have two sorts of commands: meta commands that are, say, to the framework. So we add a file to the dialog. We can also add read-only files to the dialog. A simple edit file is a file that the AI can modify, because it's anyway checked into Git. And a read-only file is, as the name implies, read-only. And if I omit the slash, I can give it directly a prompt to do something with the files it's already seeing. What I saw mostly during the early tests is that the API was rate limiting me. So in that case, Ada tries with an exponential backoff. So it first tries after several milliseconds, then 1 second, 2 seconds, 4 seconds, 8 seconds, and so on. In that case, it took 16 seconds until the prompt was accepted. So when you are experimenting with AI, this can happen to you. I think they are getting better. So this was during the early days with Anthropic Claude 3.7, which I think they were quite surprised how large the usage was. And this happened a lot to me, that the rate limit struck. Another thing, AIs cannot count. I discovered early on that when I prompt something, it doesn't follow my coding style. So it doesn't analyze the C code and tries to emulate my coding coding conventions. So the first thing I did was letting Ada write the coding conventions for me, so that I could feed them back to the AI to follow my coding conventions, and I'm using restructured text. That is, for anyone familiar with Python documentation, it's the thing Sphinx uses when you're writing documentation. And the syntax, as implied here, is you write a headline and then you underline it with different underlining styles, and the compiler infers the structure of the document from the different underlines. And what I saw is that the underlines don't fit. So you have to, the underlining has to be the same width as the headline, and it didn't produce the correct underlines. They were always too short. The fun fact is that you can make the underline longer, then it is not a syntax error, but when it's shorter, it's a syntax error. So the AI is not able to correctly underline things in restructured text. This might have gotten better with later models, but with Claude 3.7, this was not the case. A colleague of mine did some experiments with AIs counting, count the number of T's in this word or something like that. And it almost never gets it right. When you know something about how an AI works internally, this is no surprise, because the AI does not see individual characters. It's only seeing tokens, and it of course does not know what characters constitute that token. So it's no surprise, but seeing that dialogue my friend did with the AI is really, really fun. And the real problems now start. The AI does not really understand the code. When producing that test, I had hard-coded parameters. There is a dimension in that test. I don't want to further explain what this dimension means, but it had hard-coded this dimension to 3. And I had already asked it, was this a question or no? I had already asked it to correct this 3, so it tells me I'll fix the remaining hard-coded 3 values in the test pop function and ensure proper spacing and so on and so on. Here is the corrected version, and I've excerpted that, as you can see, we still have 3s in there, and then comes my next prompt. There are still some hard-coded 3 values in there. So it took me, I think, 3 or 4 prompts until this was fixed. And it shows that what a human programmer has no problem finding out which 3s in the code refer to that dimension, and maybe there are other 3s in the code that refer to something completely different, and the AI can't figure this out, at least not in that version of Claude. And this happened quite often to me. So when you have a coding style, and I have then given it the coding style that it had produced itself after some minor edits, and it doesn't really use it. So I was unable to consistently achieve that the AI was using my coding style. One particular problem is when it produces code, say 2 sections of code with an empty line in between. This empty line is usually not an empty line. It's filled up with spaces up to the point where the preceding line, the indentation of the preceding line. So whenever you see code, say on GitHub, on a project you are maintaining and someone claims they have written it themselves, and you see something like that, it's a clear indication they didn't. So it's done by an AI. I found this, maybe you've heard this thing where someone used OpenClaw as a GitHub programmer and was giving a pull request to the matplotlib project. This also, you can also see the indications that it was AI generated code. Another thing was a person in that case who submitted a bug report to another project, also indicating they had not used any AI, and you also see this telltale sign of AI generated code. So it's common, and this is one indication, and I guess it will sooner or later go away, but I did not achieve conforming code to a coding style. So the first experiment was quite a complex change. I was using a sorting algorithm. It's called non-dominated sorting, when you have a genetic algorithm with several goal functions, objectives, so it's called multi-objective optimization. Say you have a car and you're optimizing it for low fuel usage and for power, for maximum power. Then you have a compromise. So you will have one instance of a car that is really good at power, but not very good at fuel usage, and vice versa, the other way around, concerning a car that is good at fuel usage, but probably doesn't have much power. So what you get is a front of compromises. It's called a Pareto front, after an Italian mathematician who first formalized that concept, and you are sorting by Pareto dominance, so a point on that front that is strictly better than all other points, or some other points, dominates these points, so that's Pareto dominance, and you can sort by Pareto dominance. And this sorting is, in the first publication where this was done, the sorting is of the order of n squared. So you know bubble sort probably. Bubble sort is a sorting algorithm with n squared order. And I was trying to get rid of the n squared property of that sorting. And there is a paper from 2003 which proposed changes how you could do that. And I was giving it excerpts from that paper, and the prompt was to do better sorting. And then I started this and got C code like this. And when you look at that code, many of you who are doing programming will recognize that this is a bubble sort algorithm. And the bubble sort is n squared, which I wanted to get rid of, which I had included in the prompt. And the first thing it does is program a bubble sort there. And I was quite surprised, because I think no programmer would use such a code in production. I hope so, because there are library functions which are much better. In C, there is qsort, which is also in the next prompt. But this is the next prompt. So it's on the order of n squared. Please use something that's better. And I was quite surprised that the AI generates this code. My hypothesis is that it was also trained on, say, where several programmers have to produce something in a very short time, like a competition or something, and where code quality doesn't matter. So it may well be that it comes from such training data, but we don't know the training data. But I was surprised, and there was not only one instance of bubble sort, it had several. So that's one of the things you should be aware of. And it also tells you that my original title, that I'm doing wipe coding, is not really correct, because I'm looking at the code, I'm understanding the code, and I'm fixing it so that it conforms to what I want to see in my project. So I'm not really letting the AI do everything, because after these experiences, you can't. Some more details on that algorithm. Jensen published this in 2003. I wouldn't have started this because it's mostly chore. When you have a genetic algorithm, the main effort is not in how the internal workings of the genetic algorithm are optimized. Usually you call an external method that gives you how good this individual is. So you have some function that tells you how good the individual is, and this function usually involves something that is computationally costly. For example, I was optimizing antennas, so every call of that evaluation function is very costly because it involves an antenna simulation. And so it's something nice to have this algorithm, but it's not something that is really crucial. The framework generated by Ada was quite good, so I was quite satisfied with it. It got some things wrong, like a sorting macro, a comparison macro was used wrong, so the genetic algorithm didn't minimize something, but instead maximized it. But that is easily taken care of by fixing the call of that macro. And of course, the code wasn't working on first try, and I didn't try to make it work using prompts. Instead, I applied my own thinking and did it that way. The problem is really complex. There's a later paper 10 years later, actually, in 2013, of people who tried to implement Jensen's algorithm, and they write that Jensen more or less hand-wavingly describes that this algorithm is quite simple. We beg to disagree, and they describe what they discovered while implementing that algorithm. So it is really, I think, a good test for an AI, because it's really a problem that's worth solving. Another experiment, which I also needed for that, is a median finding algorithm. You are probably aware that it's easy to compute the middle, average, thanks. The average is easy to compute. It's O von n, so you have to go over all items in a list and add them together and divide by the number of items. There is also an O von n median finding algorithm. So when you sort all the items in a list and you take the middle one, that's the median. And it's not so obvious how without sorting you can find the median in O of n times. Sorting is more complicated because sorting takes O of n log n, and median finding is actually cheaper. It's possible, and I was trying to implement that algorithm. I had code in C on a web page, and I asked Ada to use that code to just translate it to C. This code had some peculiarities. It had two functions that were calling each other recursively. And it looks like Claude tried to unroll these calls, and it ended up with 4 functions that dubiously called each other. I didn't even try the code because it was really convoluted. So it got confused by these recursive calls in the other function. In the end, I wrote that code by hand. It's easy to translate Python to C, but for some things, AI is not really prepared to do this yet. So it was quite a stony way with that C code. Lots and lots of coding style violations. I didn't even try to make the AI to obey the coding rules in the end. I just changed it by hand and did a git commit, git rebase cycle. It had variable declarations in the middle of the code. You don't want that in C usually. You want the variable declarations at the top of some structure. It is syntactically correct meanwhile, so newer versions of C allow you to do this, but it's still not the style I prefer. I was unable to make it declare variables at the start. As already told, it produced quadratic code, so bubble sort and things like that, several times, not just once. I usually saw several false starts, so it got confused and I started all over. This was not context window related. So when you are using an AI for a longer time, you can saturate the context window and then after a certain point you get only junk. This was not it. It probably depends on how inventive the AI is configured. Ada does that quite good, so you can I think it's the temperature. You can set the temperature of the AI, and if the temperature is higher, it gets very inventive, but very, so you are trying when you are programming to not do this with very high temperature. And the things I have seen versus the Python project, which I'm going to show you next, is the Claude version. So Claude 3.7 versus 4. And I think this is much of the problem. I don't think it's related to the programming language C versus Python. I think that the AI is equally good at code, maybe a little less good at coding C, because out there you probably find a lot more Python code than C code. I think Python has made it to #1 programming language worldwide in the meanwhile, but it's quite good at doing C. And I think it's due to the complexity of the problem. I already told you that a 10-year later paper agreed that the problem is complex. So no wonder the AI was not that successful. My first call to Python, I have to step back a little. I'm doing a project together with my daughter. She studies music. I presented this last year here at the Python conference. The project is called Contrapunctus. Counterpoint is a musical technique where you have two voices or more voices which try to go in different directions and still do correct harmonies. Counterpoint is a very old technique. We have this since 500 years or something. People wrote a lot about counterpoint, mainly to teach other people to learn music, to learn improvisation, for example. And these rules they publish are usually so explicit that you can implement them in code and check them. And our strategy there is to formulate these rules and then use a search algorithm, in our case a genetic algorithm, to find melodies that do not violate many rules. So the optimum would be if it doesn't violate any. Sometimes we find melodies that do not violate any rules, but sometimes we don't. And we had modified the code to, so to speak, as some to-dos. So we had some comments in it and some calls to not yet existing classes in the code. And when I first called it with that input file, it says, I notice that in the checks file, there are references to 2 classes that are used, but are not defined in the file. And then it lists these. I'll need to implement these classes to complete the file. Let me create the implementation. And then it did and produced quite good code. And I hadn't anticipated this. I thought I need to prompt it and everything, so it discovered that something is missing and proceeded to try to implement it. It didn't get it completely right. Because we tried these features as exceptions to existing checks. Sometimes you have melodies and you have a dissonance, and this is usually forbidden. But if the dissonance is only short and then you have a consonance again, then it's something that is allowed. So we have checks that usually should forbid something, and sometimes it's not forbidden, and we have an exception to that. And we didn't have that exception framework in place yet. That's why it was commands in the code. So the AI did not grok that this was meant as exceptions to existing codes. But then still the implementation was quite good, and we proceeded to prompt the AI to generate this exception framework and rewrite the existing methods into exception methods. And the existing code then was mostly used directly, which means the interface of the code changed a little because it was an exception to something existing, but otherwise the code it produced on the first try was quite good. And that's also a takeaway. Do not try to prompt it to do some very, very big task. It will get confused. You have to think in what order you would do things and then prompt it for smaller work, and this usually works quite good. Then the next experiment was to implement some new checks and some new exceptions. And we used, my daughter literally has lots of books on counterpoint. And we used a mobile phone to take pictures from those books. And to give you an idea how these pictures look, so you see that the quality of that scan is not really what you would expect to have when you are trying to OCR this. So what we used were several pictures from the book to prompt the AI, and we only used the pictures. We did not OCR this first or something. We just fed the pictures to Claude with some 3-line prompt to ask it to implement a new check from these, or a new exception from these descriptions in the pictures. Another version of this, as you can see, the text is in German. So this book is in German, and it's full of musical lingo that most of the people in this room probably would not understand. You have to study music to understand much of it. So this is an additional, which makes it hard for the AI, I thought, that prompting it with German special lingo language would present an obstacle. This is another example of how such a page looked like. I just want to give you an impression how good the quality of that scan was. And what we saw, so this is the prompt, I think, and it's the full thing. So we had this where we tell it the pictures contain a description of a new harmony exception. That's another exception of this. We distinguish when you have two voices, we distinguish rules that affect only one voice. We call these melody rules. And if you have rules that affects the tone in the two voices, we call it harmony rules. So that's an harmony exception here. And I ask it to implement such a new harmony exception. And then it looks at that. We only have the scanned pictures, and it should implement this new harmony check. I already said, book is in German with musical lingo, and for me, surprising result was the produced code was correct and worked on the first try. And it was not much code, so we fed it, I think, 7 pages from the book, or so, and the resulting code was, say, 3 or 4 screenful. So not really that much code, but it's surprising, it's correct, and it follows the coding convention, the existing structure. So it was a special exception class we were using, and this worked. This was, at least to me, this was surprising. Then we tried to write a test for that new method, and my daughter drew a short example with musical notation, and we tried to feed this directly to Claude, also as a graphics, and it turns out it did see that the upper thing is a violin Schlüssel key, violin key, and the lower is a bass key, and that it also saw that it's for a full, the fourth, I don't know the English term, Viervierteltakt is the German word, but it did not see the individual notes, so it cannot parse the notes, but it still produced quite a good regression test. So it could not parse the notes, but it saw that it should create something in musical notation. ABC is the notation we are using there. This is an open source musical notation framework, which is quite easy to understand. So you basically have the note and the length, and you give it how long the unit is and things like that. So it's easy to parse, and the idea is to formulate all the regression tests in ABC notation. And it got that right. It produced even an ABC notation, but not with the correct notes. But it was quite easy to fix the ABC notation then manually. So takeaway here is it does not understand musical notation, maybe not yet. Also not when the musical notation is not hand-drawn, as in this case. You can see that that most of it is handwritten, but the note lines are straight, so it's not drawn by hand, as well as the vertical bar is also not drawn by hand, or it's corrected by the drawing program to be a straight line. So, attempt at a conclusion. I had larger problems in the C project, as already indicated. The C task I gave it is much more complex than what we did in Contrapunctus, at least from my perspective. The Ada usage was still helpful. I wouldn't have started the C project without getting the scaffolding and everything from the AI, so it really helped in that case. Also interesting is that the algorithm I tried to make the AI to implement was also from something other people struggled with. So I mentioned this, that the paper from 2013 mentions that it is was a difficult problem. I also saw some weirdness when it tried to analyze a recursive code. So this should have been better. It's probably better when you have a single recursive function. This is something we see more often. It's not so usual to have two functions calling each other recursively. And the interesting thing in the Python project is that much code was really directly usable. I fixed some coding conventions. One of the coding conventions I'm using is that I don't want lines to get long. For example, like 80 characters or something. It produced lines that were longer. And I refactored some things that didn't look good to me, but essentially the code was correct. Differences between C and Python projects. So I think complexity of the task is one factor. The other factor is definitely the Claude version. So I tried, the C project was tried with Claude 3.7. The Python project was already Claude 4. And I expect that if you're using a recent Claude version, I've done other things with more recent Claude versions, and it's getting really much better. So expect much progress there. Also interesting, they are quite good at OCR. So if you're feeding it a description as a picture from a book, this works. I guess one of the things when training AIs is that they need a good OCR anyway. But the nice thing is that the users of the AI also can get to use that. German language input. It's several occasions where it did find out that my code is commented in English, and we had some German or something prompts, and it produced code in the resulting file where the comments or doc strings or whatever were in English. So that's good. It understands in what language context it currently is. It does understand musical lingo, which was also surprising to me, also to my daughter, of course. And reading sheet music doesn't work yet. There is open source software for parsing, for OCRing sheet music, so the problem is more or less solved. Maybe we get that in the future. And what the most difficult thing to know up front is when you're starting with something, it's very hard to know up front how good the results will be. So it's hard to have an estimate how long it will take. We have this joke in computer science. In German, we say, das haben wir gleich. We are ready in a minute. And this is a joke because usually it doesn't end up that way. So it doesn't get better with AI. And it has some tedious, repetitive properties where you try to prompt it for something and it doesn't proceed. I wouldn't trust it with some things. For example, I implemented an address and calendar synchronization solution where data quality really matters, and I wouldn't trust that to an AI, at least not with a lot of regression test framework around it. So take away here, don't use it for every project. And to get back to the title, don't use wipe coding. So you can use it for a weekend project, for a throwaway experiment. But if you want to maintain code that should have a longer lifetime, you should definitely understand what you're doing. Let me end with that. So.
Thank you very much for your talk. Are there any questions?
Es ist oben nicht eingeschaltet, ja. Ja.
So in any of these experiments, did you use a planning tool or made a plan for Claude to work with before just prompting it?
Not really. I did, for the big experiment in C, I did use larger excerpts from the original paper, where the algorithm is described, also in pseudocode. So you might call it that. You can discuss, outside these experiments, you can discuss architectural decisions with Ada. So that's planning, and then you can tell it, now go ahead, do it. And it does it. That works. So, but it was not done in these experiments because it was from the scope not so big. So I guess, yeah. But you should do that.
You had problem with your programming style. Is there a way to describe your programming style before you start vibe coding?
I did that. I used Ada to construct the coding style, and I slightly edited the resulting document and fed it back to Ada as an instruction, and told it to use it, and it didn't work. Yeah.
Any further questions?
Can you give positive and negative examples of, what do you say, telltale signs of vibe-coded code base when you're looking at GitHub, and the same question for pieces of music where you found these positive and negative examples of going around the rules that you found or that you established?
Okay, it's really hard. So most of the telltale signs are very syntactic, like too many spaces. So a typical human programmer would not leave trailing space on a line. Mostly, most coding styles don't want to see that. It does it. Otherwise, one thing that you often see is when you want a description like a doc string from an AI, you see something where you have one sentence and then lots of points. That's also something most humans wouldn't do in that way, but maybe they do. So it's hard to distinguish. And I think to fully answer that question, mostly you can't distinguish it. That's the problem. So not even an AI can distinguish it reliably in many cases. I don't think we will have an oracle in the future that does it.
Any more questions?
So in aviation, there is this term of staying ahead of the airplane. The idea that you don't let the airplane steer you, you already have a plan what to do in this or that cases. You're not really surprised by things going wrong. You have like the direction in your head. How does this resonate with your like attempt of a conclusion with regards to vibe coding?
Yes, definitely. I don't think you get anywhere without a plan. So I had a clear picture of what I wanted to achieve. For example, with the C code, I wanted to replace an existing sorting algorithm with something that is more performant. And in the end, I had that, but I did code. Yeah, from the resulting code, more than 40–50% was my code, and the rest was some scaffolding that the AI managed. And when you look at the time, I spent a lot of time debugging that. And it's in the problem, I guess. So when other people had problems implementing that algorithm, it probably is difficult. And I don't think without planning and without knowing where you want to go, yeah, you end up with something that, yeah, that you wouldn't use in production. Let's call it that.
Any more questions? So then, thank you very much for your
Thanks for your attention.
The next talk will be in about 2 minutes.
Oder soll ich es gleich
Lass gleich an. AI assistant in Python.
Thank you. Can you hear me? Is this? Hello, everybody. My name is Claudia Ng, and today I'm going to walk through how I built an AI assistant that references my own blog posts in Python. So I'm a data scientist, and I also like to write about data science on Substack and Medium. And my work has been published in Towards Data Science and other publications. I've written about my own career transition from finance into data science without a computer science degree. And over the years, readers have reached out to me to ask questions about how they can also break into data science without a CS degree. And while it's nice to connect with different people, I'm also human, so I can't get to every LinkedIn message in a timely manner. And that's why I built an AI assistant to help me give more personalized advice based on the blog posts that I've written. And here are the results. So I've included here a map from Google Analytics on the right, showing where the users of my AI assistant have come from. I don't think Austria is on the map yet, but maybe some of you will try after this. And so my AI assistant has now answered over 450 questions from my readers worldwide. All right, so let's jump into how I built this. My AI assistant is powered by RAG, which stands for Retrieval Augmented Generation. Who here has heard of RAG? Okay. And who has built a RAG? Very cool. Well, for the rest of you, here's a brief explanation about RAG. So it's frequently used to provide context to LLMs to minimize hallucination. And a common use case for RAG is to power customer support chatbots or Q&A chatbots with context, with internal company documents that an LLM doesn't have context to. So in my case, what I'm doing is I'm taking the LLM and I'm retrieving the most relevant blog posts related to what the user is asking. And then I give this context to the LLM so that it can generate more grounded answers based on my writing. So the heavy lifting around my system is really the search and retrieval part of retrieving the relevant context, and then passing it on to the model to give more grounded and relevant answers. So this is what the RAG architecture looks like at a high level. So my RAG system has two main pipelines. And the first pipeline is the data ingestion one, where it transforms raw text from my blog posts into vector embeddings stored in a database. And there are four main steps that I'll go through in more detail in the next section. And this pipeline runs on a weekly schedule via a cron job because I publish on Substack weekly. And then there's also the query pipeline on the bottom here. So this pipeline converts the user queries into embeddings, and then it searches and retrieves the most relevant context to the user's query, and then generates an answer. This pipeline runs in real time, so whenever a user asks a query, this pipeline runs. And it takes about a few seconds from query to answer. And then for my tech stack, you can see here I've included some logos. I'm using Python as my backend, PostgreSQL hosted on Supabase for the database layer. And then for the front end, I'm using Streamlit, which is a Python framework that lets me build the web app interface in Python instead of having to write front-end code from scratch. And then now let's dive into the data ingestion pipeline. So the first step is to fetch my data. I have a cron job that runs weekly to fetch my latest blog post from Substack. And so every Thursday, the cron job uses RSS feed to fetch my most recent Substack post. And this container on the left here shows what the raw Substack RSS feed looks like. As you can see, real-world data is messy. We have, the RSS feed returns the raw HTML, which includes tags and entities and boilerplate and so on. So I don't want to embed the blog post as is from the raw RSS feed, because it's messy, it's hard to read, and also would add noise to my search and retrieval system. So instead I clean the data, and for this I use Beautiful Soup to strip the tags, remove boilerplate phrases like subscribe and share, comment, etc. And I get what's left on the right here. So it's much cleaner, it's readable, and it has clear paragraphs and headings. So yeah, it's important to clean your data because if the embedding is messy, it will affect and mess up your search and retrieval quality down the line. So once I have my data cleaned, I have to think about how to store it in the database. And because most of my blog posts are relatively short, they're about 800 words or so, so they fit quite comfortably into a single 8,000 character chunk. And I've found that chunking at about 8,000 characters works for my data set because most of my posts are focused on one topic. And so it preserves the context of my posts, but it's definitely not the universally optimal strategy depending on what type of data you're working with. And if the chunks are too small, then the text could become too fragmented and lose context. But then on the other hand, if the chunks are too big, then they can become noisy and then affect your retrieval precision. So if you're working with longer documents, there are other strategies like sliding window overlap that could help. But in my case, it's not necessary given my content length and also the document sizes. So what I'm doing is for each chunk, I pass it into OpenAI's embedding model. The model converts the text into a numerical vector representation called an embedding. And I have an example vector embedding there on the right. And the embeddings capture the semantic meaning of the text. So, the similar chunks live closer together in a vector space. I chose this model because it's cost efficient and it's large enough to capture the meaningful semantic relationships in my blog posts for retrieval. And so I found that it gives a good balance between performance, speed, and also cost given the size of my data set. So after generating the embeddings for the posts, I store them in a database. This is what my PostgreSQL database looks like. So I have a column, of course there's a primary key, that column that I didn't include here, but there's also a column for URL, for the title of my post, when I published it, and also a dedicated PG vector column for the vector embeddings for the post. So my knowledge base is relatively small right now. I have about 70 to 80 blog posts. So I went with the simplest, most straightforward option. I chose to use Supabase, which, as I mentioned before, is a hosted PostgreSQL platform. And it supports vector similarity search through its PG vector extension. And the advantage of using this is that I don't have to maintain a separate vector database. I can just store both the post metadata as well as the vector embeddings in the same place. And so yeah, I found that it works well for small to medium data sets like mine. If you're working with a larger data set or much longer documents, then there are specialized vector database options out there. But yeah, for this case, I chose to use PostgreSQL with PG vector. And so I've covered the data ingestion pipeline now. We have the metadata for my posts as well as the embeddings in the database that we can use at query time. And then moving on to the query pipeline. This runs in real time, like I've mentioned before, when a user goes to my web page and then submits a query. So what happens is, they type in their question, and then my system takes the raw text and converts this into an embedding using the same text embedding model that I use in the data ingestion pipeline. And then for the search step, I've defined a Postgres function that performs a vector similarity search using pgvector. And it compares the query embedding to the vector embeddings of my posts and returns the top 3 posts ranked by cosine similarity score. I've set here a minimum threshold of 0.25 or 25% for the similarity threshold, meaning that if the system if there are no posts that match the user's query, then the system returns the generic message saying, oh, this query is outside of my domain expertise to avoid hallucination. So for example, if someone asks something about I don't know, like dogs, which I haven't written about, then it would return that message. And cosine similarity is definitely not a perfect metric, but it's a good enough heuristic to use. So yeah, I'm using a minimum similarity threshold to keep my AI assistant focused on data science related topics and prevent drift into unrelated questions. And then also, the important thing to note is, because I'm keeping the retrieval step inside the database, I don't have to move large vectors into the application layer, which helps simplify the architecture as well as reduce latency. But again, like I've said before, if you're working with much larger embedding data sets or need more advanced vector indexing features, you probably need to look into using a dedicated vector database. So once we've retrieved the relevant context, we can move on to generating an answer. So for the answer generation, I send the top 3 retrieved chunks as context with the system prompt to GPT-4o Mini. And I know there are better models out there. This is an older LLM to be using, but I'll talk about that in a minute. And so the model generates an answer based on the context and the system prompt that is more grounded in the retrieved post. And so in the web app itself, every answer includes citations and links to the original source posts, so the users can click through and verify their claims. And like I said, I'm using GPT-4o Mini, and there are more powerful and newer models out there. But I'm using this one because it is extremely cost efficient, but also has a large enough context window for my use case. It fits the combined prompt and retrieve context within the model's limits. And also I found that in practice, retrieval quality often matters more than the model choice for a RAG type system. So, if your retrieval step is surfacing the wrong documents, then even the best model will lead to a bad answer. And so here is a quick animation of what the AI assistant looks like. You can see, I asked a question and then it starts streaming the answer with the top three relevant posts. And as I mentioned, I'm a data scientist, so I didn't want to spend that much time on front end. So I used Streamlit to build the chatbot web app. I did add a bit of custom CSS to include a thumbs up and thumbs down feedback button at the bottom, but it's entirely optional. And then to make the chatbot feel faster, I use streaming. So, users start seeing tokens as soon as they're generated instead of waiting for the full response. And then, of course, as with anything deployed to production, we don't want to be flying blind. So I added some basic logging for observability. And every interaction is logged back to the database in a separate table. This includes the user's query, the LLM's response, the retrieved blog posts, and their similarity scores. So this gives me a clear view of what people are asking and also how well my retrieval step is working in practice. In addition to observability, I also wanted to evaluate how good my RAG system actually is. So for this, I built out an evaluation pipeline that's kind of like unit testing for RAG systems. You know, it helps answers questions like how well does AI assistant actually work? And then if I make changes to the retrieval step, does it actually help or hurt the performance? And the eval pipeline has two main steps. First is generating a synthetic data set of questions. And then second is running the benchmark. So in the first step, I wrote a script that generates synthetic questions from my data, so the chunks in my database. It loads these chunks and then uses an LLM to generate questions for each chunk. And the output I get is a JSON-L file containing question and chunk ID pairs, where each question is designed to be answerable using that specific chunk. And then in the second step, I have a separate script that runs retrieval on each of these synthetic questions using the exact pipeline that I have in production. And then it checks whether it has a correct chunk, and then whether that correct chunk appears in the top retrieved results. So how do we measure how good retrieval really is? For this, I used metrics, specifically two metrics. So recall at K and MMR at K. Starting from the right, recall at K tells us if we found the right context. So for each question, did we retrieve the correct chunk in the top K? In my case, that would be the top 3 results. And recall at K reports the percentage of questions where, yes, we did retrieve the correct chunk in the top 3. So looking at this example, let's say we have 2 relevant documents for a query. And we run it through the production pipeline, and it retrieves the top 3 results. We look at these top 3 results and find that, oh, yeah, both of the relevant documents are in the top 3. In this case, the recall at 3 would be 1 because both of the relevant documents were retrieved. So yeah, with recall at K, the higher the score, the better the system. And then the other metric on the right, sorry, I should have said left. But yeah, the other metric on the right, MMR at K stands for mean reciprocal rank. And it tells us how highly ranked the correct context is. So how it works is if the correct chunk is in position 1, then we get a score of 1. If it's in position 2, then we get a score of 1 over 2, or 0.5. And if it's in position 3, then we get a score of 1 over 3, or 0.3. And then we average this over all the questions. So the key idea here is that the LLMs generate questions from each chunk, and then I end up with a labeled data set without having to do any manual labeling. And then I run this through the benchmark on each synthetic question to check whether the correct chunk appears in the top K results. And I ran this on my own AI assistant. At the time, I had 73 blog posts, and I generated 2 synthetic questions per post. So I ended up with an evaluation set of 146 questions. And then I ran the benchmark script with different values of K. So K equals 1, 3, 5, and 10, essentially measuring whether we're retrieving the relevant chunk in the top 1, 3, 5, 10 results, and how highly it was ranked. And you can see that recall at 3 was 0.94, meaning the correct chunk appeared somewhere in the top 3 results for 94% of queries. And then MMR at 3 was 0.88, which reflects a relatively strong ranking quality. So yeah, the correct chunk was ranked very close to the top, often in position 1 about 83% of the time. And now whenever I make changes to the retrieval step, whether it's for chunking or changes to using a different embedding model or changing the search logic, I can run this eval pipeline before and after the changes to see how much I've improved or degraded the retrieval pipeline performance. And of course, my system isn't perfect, and there are things that I can improve about it. Here are a few directions that I could explore in the future. Of course, I can run more chunking experiments and tweak that logic, try different embedding models as well. Here are some other ideas. So first, to improve retrieval, I could look into adding re-rankers to improve citation quality. So this would take the top retrieved posts and then re-rank them to surface the best answers. It would be essentially like having a second stage of retrieval, like adding a second opinion to refine my results. I could also add hybrid search. So I could combine keyword matching with vector-based semantic search, which is what I have right now. This would allow me to handle a wider variety of queries where pure semantic signals might not score so well on their own. And then I could run the evaluation pipeline to see how much these improve retrieval. There are also improvements I could make on the user experience side. So I could add user login to persist chat history. I could also add memory on the session and on the user level so that answers become more coherent over time. Because right now my LLM doesn't have context from previous conversations or even previous turns. So it kind of feels like talking to a goldfish. Yeah. So yeah, now you know how my RAG AI assistant works. I've covered a lot, so let me recap. If there are three things I want you to take away from this talk, it is that one, my tech stack is relatively simple. The backend is written in Python. For the database, I'm using PostgreSQL hosted on Supabase, using the pgvector extension for vector similarity search. For the front-end layer, I'm using a Python framework called Streamlit with some custom CSS and a bit of HTML injection for aesthetic improvements. And then second, my RAG consists of two main pipelines. The data ingestion pipeline, which is a batched weekly cron job. And it runs through the 4 steps of parsing my blog posts, chunking them, embedding them, and then storing them in the database. And then I also have a query pipeline that runs in real time when users submit a question, which embeds the question, retrieves the relevant context, and then answers the question based on the retrieved context. And every time I make changes to the search or retrieval logic, I can run the evaluation pipeline to quantify how much I've improved or degraded performance. And then third is, for a RAG system, retrieval is very important. If you run evaluation steps and get terrible scores, it probably means that your RAG system is not producing coherent or useful answers. And I'd focus on investigating the retrieval quality first, because most RAG failures aren't necessarily model problems, but retrieval problems. So yeah, if your system isn't retrieving the relevant context, then even the most powerful models in the world will struggle to produce good answers. And lastly, before I move on to questions, if you'd like this, here's how you can interact with me and my project. First, this first QR code on the left, you can try out my AI assistant at assistant.ds-claudia.com and put Austria on my Google Analytics map. I've written several blog posts about how I built this RAG system, or more generally on AI engineering, so you can try asking that. And then second, the QR code in the middle. I've created a page on my website to explain the code base with interactive elements that you can click through to better understand how this all fits together. And it includes links to my GitHub repo. You're welcome to clone it and try deploying a RAG system on your own content. I've written a step-by-step production deployment guide in my Substack that's linked in on the webpage. And then lastly, if you want to follow my writing, that's the QR code on the right. I write weekly on my Substack called the AI Weekender. I write about weekend AI projects. And so thank you. I'm happy to take any questions, or you can ask my AI assistant as well.
Thank you very much for your talk. Are there questions?
Nice talk, thank you. Do you have some experience what kind of questions are typically failures that are like classified as false negatives, even though they would be in the system? I mean, do you have some experience what systematically would be misclassified?
Yeah, that's a good question. I would say in general, the AI assistant fails most with like temporal type questions because it has no concept of time. So if you ask it what was Claudia's most recent blog post, it would hallucinate and just, you know, probably come up with some blog posts, but yeah, that's where I've found instances where it doesn't do so well.
Okay, thank you.
Thank you.
Hello, thank you. My question is about testing data you collected. You said you synthetically produced questions and then LLM generated answers for these synthetic questions. I didn't get what LLM? Can you explain a bit more? Because it's like you have LLM plus RAG, and testing data also generated by LLM. Who judges correctness of the answers? Thank you.
Yeah. So let me clarify a little bit. So in the synthetic data generation step, I'm taking the chunks from like basically the embeddings of my blog posts, and then I'm using an LLM to generate the questions based on the blog post content. So for example, if I have a blog post about how my AI assistant works, then a synthetic question that the LLM comes up with could be, what is a RAG system and how does it retrieve relevant context? And then the second step of benchmarking is I take the synthetic questions that are generated, and then I run it through the same production pipeline that my AI assistant goes through, and see if it retrieves the chunk that the question was based on. So for the question on, you know, what is RAG, et cetera, does it retrieve the blog post I wrote about RAG? And then if it does appear in the top 3 chunks, that's where it gets quantified in the metrics. Does that make sense? Yeah, thanks.
Any more questions?
Thanks for your talk. In context of improving retrieval, what do you think of query translation methods? Example, given the multi-query approach, is it any reliable or?
Sorry, can you clarify what do you mean by translation methods?
The multi-query approach would be if the user produces a query, and the query gets translated into 3 different queries by an LLM, and each of these queries goes against the vector database and retrieves relevant chunks. So you have a bigger size of chunks, and possibly if the question is too short or too complicated or too scrambled, then the chance would be higher to get to relevant chunks, at least in theory. So I wanted to ask you what you think about this. So.
Yeah, that's actually an interesting question, and I've seen a couple queries where the LLM struggles to produce a good answer because the user asked something that was too brief. And so in that case, you know, like I could put in the system prompt to say, if unclear, ask the user to clarify. Or we could layer in a second step in between where it augments the query, in several different ways and produce, several different questions that we then run in the retrieval step through and produce an answer, and then see which generates better answers. That's almost like an agentic RAG workflow, which could work well. But yeah, I think that's an interesting idea that I haven't thought about, but I should put it up on my further improvements experimentation.
Hello, thank you for your presentation. The question that I have in the metrics part of your presentation is how do you adjust the metrics for false positives? Because maybe I got it wrong, but the system works because it judges the relevancy on how the LLM sees it. And how do you adjust for the cases where LLM thinks something is correct, but it isn't?
Yeah, that's a good question too. I would say there are two parts to it. One is it could be a retrieval failure, which this would catch very well using these metrics, or it could be a model failure where it retrieves the right context, but the model answer is not quite good or not quite coherent. And in that case, I would work on tweaking the system prompt, or like he suggested, maybe having a second, like a middle layer in between to augment the prompt to come up with better answers. For retrieval failures, if it's not finding the relevant context in the top 3 or so documents, there are, I could look into adding re-ranker, which would look at the retrieved results and then re-rank them to see if the document is most relevant for the query. I could look into improving chunking or changing my chunking strategy, or I could look into using a different embedding model that's perhaps more powerful and could capture the context better. So it really depends on, I would say, diagnosing where the failure is and then adjusting accordingly.
But your current system is not adjusted for those types of failure?
I did run through some of these, and so, it produces the relevant documents, more than 80% of the time, I would say. But for the rest of the 20%, if I really wanted to improve it, then yeah, there's some work to do.
Okay, thank you.
Thank you.
Any further questions? So then I have a question.
Yeah.
Did you do any tests using LLM that can be run locally with quantity-sized parameters and to see how, for this application, this would compare to a big one or a local one that can run on a laptop with a graphics card?
Yeah. In this case, I only use OpenAI's models because it's just much easier to set up. It's basically one line calling the API. But I could use Ollama or some other package to run spin up a local LLM and then run my entire pipeline through that. So that's definitely possible. I haven't done it in this case. I have tried running LLMs locally for other things, not for this RAG pipeline. And it works for simple queries. I think it would work for this too. But then if I wanted to deploy it, I'd have to think about hosting the LLM somewhere. So that's why I didn't do that.
Thank you.
Thank you.
Any further questions? So then, thank you very much for your interesting talk. So we are already ahead of the lunch break, but so thank you very much and see you all in the afternoon.
Thank you. Yeah. Thank you. I'm always open to feedback, so please come say hi and let me know what worked, what didn't work. Thank you.
weil ich glaube, man muss es irgendwie aufmachen, dass man es einschalten kann. Wenn du es aufkriegst, 1000 Runden. Da ist der Schalter, okay. Das mit der Batterie habe ich gesehen, aber ich habe mir gedacht, ich muss es oben aufmachen.
Sollte es funktionieren.
Schauen wir mal, was es tut. Das tut es. Das Ding.
Moment, wie mache ich das?
Am Hemd so. So.
Check.
Genau. Und das am besten in die Tasche stecken oder so anklemmen. Geht alles. Ist gut. Jetzt machen wir Test.
Test.
Machen wir alles an. 1, 2. Welches ist das jetzt?
Probieren wir es aus. Try and error.
1, 2. 1, 2. It's always the last one. 1, 2. 1, 2. Nein, es gibt gar keins. Das ist ziemlich sicher das. Das lassen wir mal lieber haben. Das ist die untere Lautsprecher.
Sieht gut aus?
Yes. Schaut gut aus. Und dann einfach nur umstecken.
Ich verstehe es nicht. Also es tut nichts.
Okay, warte, dann wollte man sich auskennen.
Brauchen wir mehr als ein Mikrofon eigentlich?
Nein, brauchen wir nicht.
Ja.
Ich denke, wir kommen mit einem Mikro aus, oder?
Sollten wir, ja. RF Mute off. Jetzt ist das Mute aus. Na gut. Man muss
Darf ich zurückhaben, oder?
Ja, sicher.
Okay, das ist auch genau Punkt.
Okay.
Okay, welcome with me, the speaker for the next talk, Gabor, talking about from imports to innovation, something about Python's evolution. We are looking forward to the talk.
Thank you very much for the introduction, and let me get started by saying a few words as a disclaimer. My name is Gabor Mészáros, and I'll be presenting on a heavily network science topic, while not being a full-fledged network scientist, to be honest. My background, if anything, is formally mathematics. From that, I transitioned into software engineering at various capacities, being employed, being a freelancer. And a couple of years ago, I had this very unique opportunity of rejoining academia in the frame of joining a research group in network science. I had heard things about network science in general by then, vague terms, and I wanted to get to the bottom of what it might be. So it was a very easy call to accept the role, and I basically jumped on this as a undercover programmer trying to understand what network science is all about, how do they pursue research, what it looks like. And in today's talk, I would like to do two things. First, present you with a research topic that we pursued and found some interesting results in, And as a secondary objective, I would like to just unveil a bit on how research in network science looks like. It's definitely fundamentally different from what you experience as a software engineer in their daily work. And even as a former mathematician, I was surprised more than once in what sort of differences can be found there. It definitely starts with the data. To the very extent that I vividly recall a conversation in the department kitchen when one of the assistant professor told us very enthusiastically that we're trying a new approach, like a brand new approach. This time, we're going to take a question and then see if we can find a data supporting it. I was like, that sounds wonderful, but isn't that the way we do it? And it turned out, no, that's the exact opposite. Normally, a network scientist grabs whatever data is available, and once you have it, you'll just squeeze something out of it, and eventually you'll have a question by the end that, oh, yeah, I have always meant to answer this, and look, here's the data for it. So it's only fitting if we also, in this talk, start with what sort of data we are discussing. So let's dive into that. Please raise your hand if you are very confident that you can name what sort of data is on the chart. I grabbed this from a site. X-axis is time, y-axis is counts. That's my, okay, so we got one. Maybe let's have a closer look. Still hiding the headers. No more takers? What would be your guess? And there we go, we have our winner. So exactly, this is Stack Overflow questions and answers. 15 years of history with the count, starting from the ripe year of 2008 up until, well, we all know what happened after that. We have 15 years of history of Stack Overflow with all the questions and answers there available that you can still visit if you feel like. But as you can see, not many people do that anymore. What is more, and might be surprising for all of us, is that not only you can access every single page, there's a way to get all Stack Overflow data, all the questions, all the answers, access in a single download, in a single dump, a big one for that, where you can basically have all the history that tells everything about our 15 years of asking and answering the questions on Stack Overflow, and that's available publicly. So we jump on that data set, and what you can see on the right-hand side, by the way, is allegedly the very first Stack Overflow question containing a Python import statement from 2008. And of course, we can do the same thing, and we actually did do for many languages. You can extract language-specific data from Stack Overflow. In this talk, we'll be focusing on the Python aspect of that. And our main goal is turning these pages and all the XML half structured as they were, turn into something more consumable and something that we can analyze. So we basically downloaded the dump and processed these pages, extracted the Python tagged post, and even within them, we were only interested in those that contain code snippets, and even within that, we focused on those that contain import statements. Why import? I'll tell you in a moment. But that was basically our step one data processing piece. And we had that. It took a few weeks of time. That was very early with the ChatGPT hype. So we did use LLM support. We did make use of that. I'm pretty sure that we would have a much easier time if we were to do that again from scratch. Having accomplished that, we rewarded ourselves with quite a few plots. And we were focusing on the distribution of the libraries, all the rules that can be said about that. We were looking into very popular libraries, nothing that surprises you. I was actually surprised that Django, as web framework, almost made the top 10. And you cannot see a second one, Flask, FastAPI, anything around them. So, but apart from that, I believe that nothing in the top 5 to top 10 surprises us. Fast forwarding a few slides that I'm not going to bore you with. Fine. Finally, we obtain the data. We know we want to focus on that. What sort of questions do we want to ask? Well, first of all, I have the data. That's good. And I have the data. I felt like it would be great to just disseminate it. So now you can have it as well. So just take a quick photo, and you can download the Python-specific packages, the whole shebang of history with imports from 2008 till 2023. give or take. In addition to that, now we need a question that I promised. And our question was around the evolution of Python with focus on the innovation aspect, which is a slippery slope, as you will see in a second. So what do we really mean by innovation? We need a proper definition, like the former mathematician in me is craving for a proper definition of innovation. We're not going to get that. It turned out that we were running with the catchphrase, novelties are innovation's driving force, which is very catchy at first glance, but once you start thinking about it, we're pretty much saying, in order to have new things, we need new things. Now, there is this debate that what separates novelty from innovation, and this is a Pandora's box I'm not going to open today. So for today's discussion, a semi-formal definition of innovation will be basically we are tracking how new things appear, but it could be a new car, it could be a new text message, or the very information that there are, say, 10 to 12 people in this room is a very brand new piece of information for you, and they're not on the same scale. So we need something that is comparable. For that, we want to take a system and find its atomic, smallest possible pieces and see how this system evolves over time, how we have new things entering it on that elementary level. We have more than a decade long of research history of how new things enter systems, and there is a generally accepted law, it's called Heap's law, that says that over time, the rate at which new things appear in your system will start to kind of flatten out, slow down. Imagine that you're writing a book. On your first page, you need to place the story and the plot in space, in time. You need to name the main characters. You need to give some characteristics. You need to create some sort of a tension, and so on and so forth. And by page 100, you'll be repeating the same things over and over again. You're bringing in new things, but obviously, the words are being reused. You need fewer words to kind of keep the plot going. They did do research initially on text coming from novels, text coming from social media platforms, and so on and so forth. And they did verify that regardless of where you look, that sort of a sublinear pattern will appear. So novelty as is, new things are entering the scene at a decreasing rate. Is that a bad thing? If we believe that innovation is thriving, if we have many new things coming in, and we know that the rate is basically flattening out, so are we doomed then? Does it mean that it's the end of the story? Not yet, because many people argue that it's not the amount of new things, but it's more like how we can combine them. There is power in recombinant growth. So I can take two old things, we have known them for ages, and combine them together, and we create something that nobody has ever used, and that will be our novelty. So novelty shouldn't be measured just in terms of the atomic blocks, but how they can be recombined. And there is power in that because we know by elementary combinatorics that we can have a quadratic growth in that. Out of 3 elements, I can create 3 pairs. Out of 5 elements, I can create 10 pairs, almost said 6, but 10 pairs, and so on and so forth. So there is a growth rate there that we could make use of. And the research on which we anchored our work was a decade-old result coming from HS1 and co-authors who studied that sort of a growth rate of individual elements and pairs in the US patent system. So whenever you submit a patent and it goes through all the validation process, of course it receives a unique identifier, all sorts of metadata, but as part of the process it also receives code words, patent codes, describing what sort of technologies are being used. It might be saying that there are some metallic pieces, some electricity involved, and basically there is a drill down system expressing what sort of combination of elementary technology types are involved in the creation. The patent history goes back all the way to several hundred years, starting with very early inventions like my favorite pick is the mustache guard, a very elaborate piece of technology of its age, maybe described by 1 or 2 code words. And I'm not surprising anybody from saying that at that point in time they had no patent code word for nanotechnology, internal combustion engines, and so on and so forth. So as science advanced, they had to come up with newer and newer code words to describe these technologies. So the set of code words grew. What Yoon and the co-authors did, they took a look at these code words and how rapidly they grew. And they could see that on individual code word level, the heaps type of sublinear growth can be seen, which was not surprising at that point in time. So if you take a look at the black circles, basically flattening out on that log-log scale, you can see that heaps curve over there. However, what they also saw was that the pairs sustained a surprisingly stable linear in the log-log scale relation, pretty much indicating that although we are fewer new things to cook with, we could still take whatever we had and generate many more combinations. Most of these combinations, by the way, that's not immediate from the chart, but you can verify that, are coming from combination of old things, as I mentioned. I know technology A, I've used it for ages, same applies for B, but A and B combined together, that's innovation. That's something that nobody has thought of before. And we have many of these things, and they could verify over more than 100 years of history that patents behaved like this. So we really like this result. And we were wondering what's so special about patents that they can behave like that. And human invention and creativity is universal. It should appear all over the place. What if we were playing the same game with Python packages, Python imports coming from Stack Overflow posts? So instead of a patent submission, we'll have a Stack Overflow submission, question or answer. Instead of a patent code, we'll have an import statement with a reference to the library. And code pairs will map naturally to co-import, meaning two libraries appearing in the same code snippet. What will we find if we, now that we have harvested all that Stack Overflow data, what will we find if we were to do the same mapping process? But does it look familiar? We have singletons flattening out the same way new words did, new posts did, patents did. But we also have a surprising regularity, the same regularity we saw for patents appearing for code pairs. Of course, everybody has used import numpy and import pandas with a statement, but has it ever occurred to you to use import OS and import numpy, or you name it? We can see that by just following these posts that the same richness, the same sustained linear growth appears the same way we saw in case of patents. And of course, we could finish the talk just like that. That's an interesting phenomenon that has nothing to do with patents, but the story feels incomplete, to be honest. So why is it that this works for patents, and the same thing seems to be working for Python imports? And this is outside the scope of this talk, but I can just please take my word for it. If you do the same thing for C++ libraries, or you name, we did it for 12 different mainstream languages, and to different extent, we did see the same pattern. Of course, Python was one of the most prolific of these Stack Overflow posts. We had more than 1 million entries with code words, whereas for languages like Julia, we had less than 10K. So it's not the same football field, to be honest. And it's not a fair comparison saying if Julia is following it any better or worse than Python. So in the remainder of the talk, I would like to talk a little bit about one potential explanation of why this happens for patents and why this happens for import statements in programming. The two have seemingly nothing to do with one another. And the common root, the common denominator has nothing to do with, I would say, the fields. The connecting piece is the human in the center and the way we invent. There is a very famous model in network science called the adjacent possible that will be demonstrating or semi-demonstrating today by using a so-called POIA's EARN model. It's a hypothetical model that can be implemented, that can be used for simulation, that kind of explains how new things can enter a system via a well-defined probabilistic process instead of something highly abstract. So let me say a few words about this model. Imagine an urn with 10 balls of different colors, red, blue, yellow, you name it. And we're going to generate a random sequence of colors. These are our imports, these are our pattern codes, whatnot. The way we do that, we keep pulling and then reinserting these. Now, if we don't do anything but that, that's a very nice elementary combinatorics problem, probability problem, and you'll have a sequence. Not a deterministic sequence, a probabilistic sequence. But we want to capture how certain technologies become mainstream over time. So it's not a constant size urn. We start with 10 balls of different colors. And we apply 2 rules. One of them is called reinforcement, pretty much saying if I'm using something, it will become more likely that somebody else will start using it as well. We reward the color yellow when we pull it by, of course, reinserting and adding a few more yellow balls, pretty much saying now I have a higher probability that next time I'll get the same color. That's good. That expresses something, that captures something that is very human, very typical. If we see something, we might start looking into it and maybe seeing if we can make use of that too. That's also part of innovation. However, if we only have this rule, we'll have more and more balls, but we're still stuck with 10 colors only, right? So what we need is another dimension, another angle, and that's what we call the expansion. Pretty much saying that, let's say, this is the very first time I'm pulling the color yellow. Yes, chances are somebody else will reuse it. But it's also possible that somebody will take a look and they'll be like, I could do something like that, but not exactly that. And that's innovation also. Pretty much saying that I can tweak this to be more suitable for my purposes. We capture that by saying that every time we pull a color that we have not seen, not only we throw it back and of course we reinforce on it, but we take different shades of it. So instead of yellow, I'll add an orange. And give me another yellow shade, I don't know, variant. So we add new colors to the system. And those 2 effects will be that shapes how this whole process unfolds. This is the urn model. It's also a well understood model, and we can very well model the heaps curve and how it develops. So there are tons of papers on that. So one more time, I'm basically just doubling down on the 2 rules. If I'm pulling a color, I need to reinforce it, adding a few more. That's the reinforcement parameter. If I'm pulling a color the first time, I'm basically creating variants of it and I'm throwing them back into the urn as well. And these 2 driving forces will tell us how the urn looks like, and that will also guide how we pull the colors and how we form our eventual sequence. The reason I'm telling about the urn model is because we were hoping that this well understood model will work well in understanding and explaining what we are seeing for the pairs, the novel pairs, the co-occurrences. So the way of verifying it would go like this. I can fit an urn model by tweaking the parameters and the initial size to meet the heaps curve. Today that's not complicated. However, what happens is I want to see with that generated process, how close can I get to the eventual pairs? If both curves are mapped with the same parameters fairly close, then we say that's a faithful representation. So we basically generate a sequence using the urn model. We calculate the new singletons, we calculate the new pairs, and see how close we can get. And we didn't do a tremendous job getting very close. What we could see was that, yes, we can get very close to the individuals, as you can see. We have a fairly decent R2 accuracy on it. And we have an overshoot, so we're not getting the story just fine and just right. However, the rate at which the imagined curve grows pretty much matches the original one. So we took a look and we started analyzing, so why could it happen that it looks good, the rate is okay, but it's kind of off by means of some constant multiplier maybe. And it pretty much boils down to one thing, human limits, our cognitive limit. In our EARN model, potentially any pair of colors can be combined. I might be pulling a red and a yellow, or a red and a blue, or a red and a black. Humans can try to imitate that by combining two arbitrarily chosen things. It doesn't always work out just fine. We typically specialize in a certain field, so we can fetch the libraries from there, and we might have something that we kind of understand that it's nearby, and we can combine from there, but we won't be able to reach every corner of the system, and that's an overshoot in the model that should be taken care of. We did spend some time looking into alternative or more complex models, where we say that we want to put some limits on what sort of pairs can be formed, and the results were mixed. And at that point, let me just kind of address the elephant in the room. Not this one, the elephant in the room. Our initial EARN model already has 3 parameters. Initial size, reinforcement, expansion. So 3 parameters, right? Now, we could introduce a number of different EARNs. We could introduce alternative approaches. But at that point, we should be reminded that at the end of the day, the model is only as good as much as it can describe the system. Now, if I present you with a model of 17 parameters that fits everything to 100%, you'll be like, okay, but what does that tell about humans? What does it tell about the process? 17 parameters cannot tell anything meaningful at that point. That's beyond our cognitive capacity. So what we ended up realizing is that the EARN model faithfully described the process with some potential overshoot that we do understand, but it also was a sufficiently good description of what happens in the background, so we kind of stopped at that. There is still additional work that is part of our paper addressing that, definitely not scope of today's discussion. So with all of that, thank you for your attention. This was a joint work with my former colleagues Luca Gallo and Johannes Wachs from Corvinus University, and I hope you found it insightful.
Questions? No questions? The double log indicates that a straight line is a polynomial, right?
There's a power series growth in that. Polynomial, I'm not sure if... So let me start by saying that the log-log scale hides a lot.
Yes,
so it
but I think a straight line would be a polynomial.
Could be, but you can also have all sorts of noise around that you won't be seeing.
Yes, but it's not exponential. So I wonder, shouldn't we see exponential growth somewhere? Because everything you look at, many things grow exponentially, and
there is a certain limit on the growth. Yes. So let me go back to single novelties being bound by heaps log, right? Yeah. Now, if at a certain point of time you have n to the alpha new elements entering, that immediately puts a limit on how many pairs you can form, right? So that n choose 2 rule applies on that n to the alpha. So it can push it up to linear. If that alpha exponent happens to be over 0.5, then n to the 2 alpha can be super linear, but we won't be getting exponential out of it. You're right that all the subsets are exponential, but we are only forming pairs. And there are different directions of research saying that, yeah, let's focus on triplets. That's still not exponential. That remains polynomial. So in general, unfortunately, we have these sort of bounds simply coming from combinatorics.
Great talk. Did you consider applying this one level higher? So instead of doing Python packages, did you consider doing Python and R, Python and Node.js, so a mix of programming languages or different databases, ecosystems, and technologies?
Thank you for the question. We did not, and that's definitely a potential direction. For that, you would need a bit more than the data I shared on it, and I'm more than happy to share that too. So if you want to have all the extracted posts, that's like a 7 gigabyte JSON zip. Kind of tricky in Stack Overflow. I do believe that the tagging is rather strict, so you wouldn't find that many posts with mixed JavaScript plus Python tagging. I'm not saying it's not there. It's probably a negligible amount of posts compared to what you have, like a 1.5 million purely Python posts is something that you can make use of. A handful of combinations are just not a critical mass to analyze. And I can imagine that some of the Stack Overflow posts address that, but in my experience using it, most of the questions were just focusing on a single, how do I do this import, how do I do this in that programming language instead of doing the mix. So what I'm trying to say is that the question itself makes a lot of sense. Stack Overflow might not be the best resource for that, and as we discussed, we take the resource first and then we ask the questions. So that was more like the fundamentally new approach of let's just ask a question and see if we can answer it. Very brave. Thank you.
Thank you. Any further questions? And let's give a warm applause.
Thank you.
Sonst alles gut gegangen? Alles gut gegangen?
Ja, ja, super. Der war halt schnell fertig, aber das ist ja auch okay. Ja. Nichts.
Yeah. And I was just telling somebody there really should be some kind of minimum requirement for running Linux more than just I have a crappy old laptop. Because if you're that guy who just plays with it every once in a while, all of a sudden you have to sign in every time on the command line because your desktop environment doesn't load on its own anymore.
Okay. Yeah. Yeah.
All right.
Well, let's hope it works.
Yeah. Let me see. That and
Yeah, the limit is fluid.
Carl Friedrich Gauss didn't
People
have machines.
tell me if you do it with Excel, it's not AI according to the AI Act.
Yeah.
Because
Yeah.
in a different topic we were discussing that.
Right.
What is AI?
I was on the Carl Friedrich Gauss did not have access to these machines. It can't be machine learning when he did this. And then I found out that Legendre published it first. But Gauss said that, oh yeah, I've been using that for 10 years when Legendre published his treatise on least squares. So it kind of depends on who you want to give credit to. Like Gauss, it's the Gauss mark.
Do you want a maker like that or this one?
I would prefer that one because I moved too
Yes,
much.
do that. Let's do it.
Yeah. Is that how you turn it on? Okay.
Discover the hard way. 1, 2.
Oh, perfect.
And you.
Yeah. I guess I should do this in the right order, shouldn't I? This is
1, 2.
Okay. Test on the mic. 1, 2, 1, 2.
That's good.
Yep.
Yeah.
All right. Hey.
There's still 3 minutes left.
Yeah, and probably 5. I tend to start 2 minutes late because everyone shows up.
You are online now, you know. So don't say anything.
Nothing. No more ranting about the fact that machine learning doesn't exist.
Yes.
Because Gauss is older than machines.
So you manage with the slides so that.
We do to conserve RAM and processing power on old computers. No. Are there not data people here that are just kind of?
What do you mean by that?
I don't.
At the moment, I'm studying data science.
Okay.
So I don't know if you already consider me as a data person.
I don't either. It's how you consider you. I have collected careers, some of which I'm still very much attached to. I've gotten in discussion about linguistics more than once this week.
So let's start.
Yeah.
Welcome with me, James, with the next talk on insights on feature selection. So welcome, James, and we are looking forward to your talk.
Thank you. Hi, I'm James, and today we're going to talk about feature selection, what your model can't tell you. So we are all big on learning from the data, but there are other things that we can learn from besides the data. And I know that there are parts of you inside that are going, wait, you're bringing outside assumptions to the data. You're not letting the data speak for themselves, and that's good. Keep thinking that. That's what you should. Yeah.
we're all gonna end up there because, yeah, we want to learn from the data, but we want to learn properly from the data. And if that doesn't make sense, it hopefully will in just a second. First of all, a little introduction. My name is James. I'm from Nashville, Tennessee, living in Hamburg, Germany. I am a recovering academic. My focus was macroeconomic labor, and then I got a little into computational econometrics, and that led relatively easily to machine learning because really so much of this machine learning stuff is just some kind of gradient to say you've got a loss function, you minimize it, right? And there are a bunch of different ways to do it. They're all very fun, very interesting. I am into all of them. And I, like I said, collect random information, past careers, whitewater rafting to vermicompost. That's worms eating your trash. That is the technical term for it. If you've ever wondered, what do you call it when worms make compost? Because it's not really compost, it's worm poop. It's vermicompost. I want to know a little about you guys from what I haven't asked already. How do you choose your variables? Who uses lasso ridge, ANOVA, chi-squared, something like that? Is that anybody? That's your thing? Anybody else? Who's going to your modeling questions with some kind of model comparison? You're looking R squared, mean squared error, AIC, BIC, Bayesian model averaging, all of the things, right? Yeah, you too. Who's doing some graphical analysis? Put it on a histogram, see the distributional assumptions. Yeah, exactly. You are on it. You were doing, I like that. I like that. Yeah, and it's great. You want to graph your data. You want to see what that looks like, right? Who is just going to everybody else who's working on a similar problem and say, you put in gender, I put in gender. You put in years of education, I put in years. Is anybody doing that? Yeah, a little bit. Yeah, then nothing wrong. Ain't no shame in that game. Who is just throwing all the data into the model and just stirring it, right? I believe there was an XKCD about that I've forgotten to use. Who is a little worried about confounding variables? Yeah, it's something a couple of us have heard of, right? Confounders or as we in economics like to call them, bad controls. That's kind of what I'm focusing on today, is a lot of that stuff on the upper part, that's all stuff your data can tell you, but there are some things your eyeballs can tell you. Obviously, there's an XKCD that we have to do. If you don't control for confounding variables, they'll mask the real effect and mislead you, but if you control for too many variables, your choices will shape the data and you will mislead yourself. Somewhere in the middle is the sweet spot where you do both, making you doubly wrong. Stats are a farce, and the truth is unknowable. See you next PyCon Austria. So we're going to do a little groundwork here, kind of because what we love to do in statistics is mess with terminology, right? It's always nice when you have two words for the same thing in statistics that in the rest of the world mean the exact opposite. That happens, I think, more than once. We're going to focus here on the basic linear model. And so that's this standard y equals beta null plus beta 1 x1 plus beta 2 x2 plus beta k x k plus our little error term, right? Here's kind of a motivating example with little stuff omitted for brevity. Income depends on the gender plus the education plus the hours you work per week plus some other stuff plus an error term, right? Let's, gracias, you're my hero, yeah. Prost. A little caffeine to get me through the end of this talk. So your income, what if, for example, you want to know what the gender wage gap is? So your variable of interest here is beta 1. It's the difference, gender is 1 if you're male, 0 if you're female, then however much money in the linear framework somebody makes after controlling for the rest of the variables is beta 1. Are you guys with me so far? Yeah, okay. Here is my question. Do you want to include this X3, this weekly hours worked? Do we think that's a good idea to have that in the model? Is anybody dead set against that? That's a terrible idea. Only me. Okay, one more. 1.5 more. So here's the thing. I don't know if your mother worked or not, but my father was what we call the breadwinner. He had the full-time job. My mother, for years, didn't work. When she went back to work, she only worked part-time. Why? Me. I am the reason we can't have nice things, right? I am also my sister. Mom, as you may imagine, was a mother. If I threw up in school, she got the phone call. She had to leave work. She had to drop whatever she was doing and pick me up. Women are pushed into that caretaker role. That pushes a lot of women into part-time jobs. If you have a parameter or a feature in your model for hours per week, that is going to be lower for women because they are women. That is going to mask and artificially lower our beta 1, our variable of interest. And so that regression is going to downplay the wage gap. And that is, yeah. You see that in real world, you see that from academics, you see that from even from economists who are supposed to know better. All right, little terminology. So we're going to talk about the outcome variable is y. Yeah, question?
Yes, the question, if you just go back one slide,
Yeah.
Because I disagree weekly hours not to include, because generally, in my opinion, what you do is beforehand, you really test if you have a significance of the variable or not. And so I cannot really follow why you say I dismiss the weekly hours when it's significant. I mean, it depends on your data set, I understand that, but to drop it generally, I cannot follow.
Yeah.
James, can you try to summarize and can you signal me so that I can give you the mic for the recording?
Yeah.
And also for this.
Yeah, so the question is, should I have run through some kind of statistical analysis to say that weekly hours should be omitted instead of just saying that based on the way I feel and my kind of prior beliefs, I should just throw them out. And I'm going to get into the details a little bit later, but the idea is if you go back to the Gauss-Markov assumptions about variable independence, if I don't think that the number of hours worked is independent from the gender, if I think that women are systemically pushed into part-time jobs because of more of the burden of caretaking, childcare, or elderly care or whatever is given to women, and therefore they are less able to work full-time on a larger macroeconomic scale, then I think I'm justified in omitting weekly hours. If, I mean, maybe I pull it all and into a pandas data frame and check and see that the average weekly hours for men and women are the same, then maybe I'm going to say, okay, I don't think so. And this is just a toy example. I don't have data for this with me. You could definitely do a data analysis on that. However, as an economist, I have read multiple studies that suggest that that is a systemic thing. And so it's, and I think that is the right way to look at it, is this something that I just think, or is this backed up in the data? And that's kind of the core of what this is all about here. I'm going to move on. I'm going to come back to that at the end, I think. So generally speaking, my outcome variable is going to be y. My variable interest is usually x1. So the control or the features, the explanatory variables are x2, x3, x4, x all the way up to xk, right? And then the model, and this is the important thing for me, a model is a tiny little world where we pretend that nothing else exists. So let's say here, I only have my 3 variables. What I'm saying by this model is that income is only determined by gender, education, and how many hours you work per week. And nothing else, a little bit of statistical noise in there, and there's nothing else in the whole world. If I want something from the word, if I want to add race, if I want to add education, no, education's already in there. If I want to add years of working in the field, I have to add that. Otherwise, I just pretend that you could work in the field for 20 years and that's not going to affect your data. That's the important thing for a model. If it's not in the model, it's not in kind of your little world. Because we build worlds, don't we? That's what a model is. There's a great book, Escape from Model Land. Highly recommend it. Can't remember the author off the top of my head. But she talks about that stuff in great detail. And I may or may not talk about a latent variable. Latent just means you can't see it, you can't measure it. Economists love to talk about happiness or ability, right? It would be great if I could have included ability in all my labor market models. But what's your ability? Who can give me numerically their Python ability? I have a 2. I mean, that's you can't accurately measure that, and I'm sure there are people with 1 who have higher Python skills than me. This talk also gets into causality. You know, XKCD, I used to think that correlation implied causality. Then I took a statistics class, now I don't. It sounds like the class helped. Well, maybe. We have our cue ball statistician not wanting to assume causality because that's what we're taught. Correlation is not causality. Correlation is not causality. All of a sudden, I'm saying that there's a causal thing in the labor market that makes women work part-time more than men, and therefore, and it is complicated, and correlation doesn't imply causality, but it does wiggle its eyebrows a little bit, right? Because we know that things cause things, right? We know we can build a causal framework. I'm going to come back to that in a second. Causal framework I like to use is the DAG, the directical. Have a little more coffee. Thank you for waiting. Directional acyclical graph. No one says that. They all say DAG. So directional, everything has a direction. You have to choose. Does it go from A to B or B to A? Acyclical, no takesies, backsies. I can't prefer apples to bananas and then prefer bananas to strawberries and then prefer strawberries to apples because then I had to prove that in microeconomics. Moss-Callel, Winston, and Green. Terrible textbook. Unless you really, really like microeconomics, and then they are gods. That's not me. So all the edges have arrows, but only one direction arrows, no repeating. If there is no arrow, there is no causal flow, there is no connection. But chains become very important here. So an easy start, we have 2 things. We have smoking and cancer, right? And I think we all know how the causal flow on that goes because we all, who is it? Ronald Fisher spoke about this, I believe. You know Fisherian statistics? Fisher, the guy who made the confidence interval so popular. We all know that cancer causes smoking. That is a wide-held medical belief. The problem is cancer starts really early and really slow, and it's really painful. And so people who have lung cancer tend to try to reach out anything to soothe that cancer, and they find these cigarettes. And the cigarettes go directly to the cancer and make it feel better until 10, 15 years later, the cancer grows and becomes obvious, and then the patient dies. I know, I'm here. But until the 1950s, great doctors, and even into the 60s, and a few holdouts in the 70s, medical professionals believed that cancer caused smoking. And now we're going the right way, but this really explains how tricky this stuff can be. And that's why that question is so important, is do we have statistical evidence to say that this arrow exists? And when we do, are we sure we're going in the right direction? There's so much talk of reverse causality. There's a lot of a kind of nerdy debate in the economics world. On the sociology side, does crime cause police, or do police cause crime? How many people get arrested with no police involved? We don't measure crime, we measure arrests. Police do the arresting. Do police cause crime? Does crime it's a complicated question. I don't want to get into it here today. I want to get into a little bit of a deeper picture at the moment, as we're moving on with time. Expand the smoking. I'm going to argue here, smoking causes jazz. Right? I'm glad you guys agree. Because it was jazz or leather jackets. And you know, I had a vegan lunch. I'm going to leave it. So you start smoking cigarettes and you're like, you know what, man? John Coltrane. Yeah, right? Absolutely. I'm glad. For those of you who don't know, John Coltrane was an alto saxophone player. It was great jazz. John Coltrane, Blue Train. One of my favorite albums of all time. What about stress? Stress, I would say it causes smoking. Is anybody cigarettes, nicotine, present or former? Yeah. I smoked cigarettes off and on for a number of years, and yeah, I feel like stress causes smoking. Smoking causes cancer. What else causes cancer? Genetics, right? So here, we have some interesting flows. I want to point out that I don't believe that genetics and jazz are connected. Therefore, there is no arrow there, right? Stress and jazz, I don't believe they're connected. Maybe there is some kind of, maybe there's this personality type, this latent variable of chaos loving, right? Do you know Coltrane Live in Japan? Terrible album. I mean, really great avant-garde, like pushing the boundaries of jazz, but pushing the boundaries of jazz in a 4 LP box set, much of which is just making random noises with instruments. It's not a pleasant listen. It's none of the nice melodies and soothing solos of Blue Train. But if you love chaos, you probably like jazz, you probably like stress, or at least have stress, right? Has anybody, that's certainly my experience. I'm not exactly chaos averse in parts of my life. And so you would have a latent variable up at the top with arrows pointing to both. And you can do this all day long. We can add stuff, because what else called diet stuff? And does a diet interact with stress, with smoking, with genetics? All of this, we can do this all day. We should do this all day. But right now, we're just going to stay here. And the thing is, these causal pathways, you can block. So if we have stress and cancer in the model and not smoking, you will still get, in your regression, a statistically significant relationship between stress and cancer, assuming the data are well-behaved. And we're going to assume well-behaved data today. If you add smoking to the model, there is no longer any more statistically significant correlation between stress and cancer. And the reason is everything that cancer knows about stress? It learned from smoking. Smoking already has all that information. You no longer need stress in the model, and it's no longer going to help you because there is no direct line from stress to cancer. If we expand the model and make that line, or, and here's the catch, if we don't expand that model, but in the real world there is something significant, then that stays relevant, which is actually also a statistical test that you can do of if you take out, if you leave stress in the model, add smoking to the model, and look at the significance of stress on cancer, and that remains statistically significant, you're missing a variable. And that's also great news because the next thing we're going to talk about is a form of omitted variable bias. Do you guys know Simpson's paradox? A couple of y'all? It's the idea that you get some kind of treatment that does the opposite of what you would expect. And let me give a better example. Does everybody remember that little virus that went around, COVID-19? Yeah. There was a period in Germany in early 2021, if I remember correctly, where you had unvaccinated people and vaccinated people, so two groups, that got this treatment, this vaccine. One group had low mortality, one group had high mortality, right? So, who thinks the unvaccinated people died a lot? Who thinks the vaccinated people died a lot? Okay, I would have guessed differently. I would have think you have the vaccine, you're not gonna die, right? But no, you guys are right. The vaccinated people died more, the unvaccinated people died less. How does this vaccine work if we have this going on? That's wrong. If you look at this, and this was true, the Robert Koch Institute told me so, how does this work? Can anybody think of a variable we don't have in here? Age. Yeah, it's so high risk is what it is. And I've done it in a darker green because it's a latent variable, you can't measure it, you can't see it. I mean, you can measure it. At the time, you had to get the vaccine, you had to be old. Or have an existing condition, asthma, something like this. You had to work in the medical field. And that group was a lot smaller. So that group, the vaccinated group, was getting a lot less COVID. But when they got it, they died. Because if you're 89 years old, it doesn't really matter if you have the vaccine or not. COVID is going to be problematic. And like I said earlier, this was my first time seeing Simpson's paradox in the wild, and I got really excited about that. Do we all understand Simpson's paradox now? Yeah. It's a fun little thing, right? There are a bunch of other, it's one of these, and technically it's not a paradox because it actually makes sense when you think about it in the right light, but it's one of those things we love to do in statistics is talk about a paradox without being a paradox. So raise your hand if you're familiar with selection bias, right? As you can see, most people know. Does anybody else like XKCD as much as I do? Yeah, okay, I'm just checking. The other important thing about this model building that I love so much, and that happens when you assign these flows, is you get this idea of the counterfactual analysis. And what I mean by that, this is what we can see. This is the factual. We have a treatment group and a control group. We have a treatment effect and a control outcome, right? So we look at the ATT, the average treatment effect on the treated, and then the NT, the not treated effect. We can see that, right? That's easy peasy. But we don't have the ones in bold. We don't have the average treatment effect on the not treated because they're not treated. They don't have a treatment effect. There is no AT-NT. There's no NTT. There's no non-treat, I guess TNT. I don't know why we used NTT on that. Blame the econometricians. It's the not treated effect of the treatment, so to speak. So you didn't get treated, but what was the effect on the treatment? Or what was the control outcome? Yeah. And so then I would rename the NT, the not treated effect on the not treated, so to speak. But we have these two things that we can't directly observe. That's the great thing we can do with models, right? Because my common example is macroeconomics. We have a horrible example, a horrible sample size for large economies that have gone through a major deflation. I can think of like Japan in the 90s, early 2000s. I can think of Japan. At sample size 1, right? And I know. I have been asking for years, can we get another 200 or 300 Japans? I'd settle for 100 at this point, honestly, so that we can have some kind, even if you're still working on small sample effects, I need more Japans. They don't have it. We have to build a model. We have to estimate this stuff. I'm a little low on time, so I'm going to run through real quick. Spurious correlations. Welcome to Austria. Did you know that the biomass generated in Austria has a very high correlation to GMO use in corn grown in Illinois? This is from Tyler Vigan, and you see, if you just Google spurious correlations, his site comes up, and there are literally thousands of these. And here's the problem. I mentioned using R squared to evaluate a model. This R squared is 0.98, right? And yeah, sample size 22, so it's not great. But here's the thing. Let's say you're using this model in production. What happens in 2021? Everything was going so, and that's why I saw this and I was like, yes, this is the perfect one. It's got Austria for PyCon Austria, and at the end it starts to fall apart, right? Our last data point is really starting to come unraveled. And that's the problem. This is completely spurious. There is no, you can't draw that arrow between biomass and in Austria and GMOs 7 time zones away. That doesn't exist. But statistically, we have something here. And that's why drawing those arrows is so important. Another XKCD, we can get to that. And so I want to leave you guys with just these 3 things. We have this idea of what's called the fork. So you have ice cream and drowning that are statistically correlated until you add temperature. Because temperature causes ice cream, right? How many of you guys are eating ice cream all winter just as fast as you do in the summer? No, it's just me, right? How many of you guys go swimming in the winter? I mean, yeah, it happens. How many of you guys go swimming in the summer? Right, there you go. So once you add temperature, this causal relationship drops out. And the significant, that's what Richard McElreath, who Statistical Rethinking, Richard McElreath, it's a great course on Bayesian stuff. He talks about this at length. He has what he calls the collider. So we have a light switch and a light bulb. The bulb can work or not. The switch can be on or off. These both have to be true for the light to be on, right? So if the light's not on, we know that one of these is not working. Is it the light bulb? Is it the light switch? So the light switch being on doesn't affect the light bulb. The light bulb being burned out doesn't affect the light switch until you observe that there is light, and then you know that both are working. And then you have, like I said earlier, this A causes B causes C. I love the MT-CARS data set. I don't know why. I used it in my first econometrics class. So a bigger engine gives you more horsepower, gives you lower gas mileage, right? Worse gas mileage. Once you know that something's high horsepower, you already know it's got a big engine. You're not getting 8,000 horsepower or whatever from a little scooter engine. And we have all three of those in here. I'm a little low on time, so I'm not going to go through that right now. If you guys want to, grab me afterwards. Resources. This path tracing stuff is great. What this is, it's a crash course in good and bad controls. It's an amazing website. What these guys do is go through kind of every conceivable path you can have. When is it good for statistical significance? When should you absolutely control for it? When should you absolutely not control for it? There's also a link, I believe at the bottom of the page, to a Kaggle workbook. It's in R, don't tell anybody it's not Python. You can get similar with stats, but they go through all that with simulated data. It's great. I also mentioned McElreath. He has, if you want to go through a half hour of this Science Before Statistics workshop is absolutely gold. It's about 2.5 hours, a lot more detail, a lot more into that path tracing stuff and going through why. And he's a sociology guy, so he's got some really interesting examples in there. Highly recommend him. And if you're the audio type, exactly. Yeah, that's McElreath. Nice one of these nice American voices, right? Quantitude podcast. They're two other American professors that are just wonderfully nerdy. And this episode is their control podcast. I listened to it again. It starts with a great story about drag racing an old beat up 1968 Volkswagen Beetle. Horribly entertaining, and it really gets that kind of academic side of things. And yeah, thank you guys so much. This is me on LinkedIn. Feel free to connect. Thanks.
Questions, anybody?
Questions, comments, complaints, verbal abuse. I'm open to whatever. I know you guys want to know what the real professionals say, right? You guys are checking those QR codes first. Let me find all this stuff James was wrong about, and then we'll find him tomorrow. Yeah, I'm around all day tomorrow. Feel free to grab me. I love talking about this stuff because it's so fun, and the answers are always so, well, maybe.
I like your cause of jazz.
Thank you. Yeah.
Thank you, James. I don't want to be the other woman harping on this, but I do want to understand more about the income question. Because to me, it seems to me like if you take out the weekly hours worked variable, you're answering a different question. Where, if you include weekly hours worked, I think it would help us better understand whether women are getting paid fairly for the same amount of work. Whereas if you take it out, it's a question of whether women are being pushed into working less hours, hence lower income.
Absolutely, and that goes to the question of, are we talking about hourly or monthly or yearly income? And if you, let me pull it back up, it's around here somewhere. If you leave weekly hours or hours worked in the model, then beta 1 becomes that per hour wage difference. But if you're concerned that women are pushed into part-time work and that pushes down their monthly, their yearly income, then you should not keep it in. So absolutely, it really depends on your research question or your business question, your application, and how you want to ask that, and that is exactly the right way to ask that question, because there are great reasons, and that is one of them, to keep that variable in the model. There are great reasons to kick it out. And at the end of the day, this is a horribly difficult question in the literature that economists lay awake at night thinking about, because it's so hard to measure, it's so hard to model, because you can't isolate these effects. And part-time jobs pay hourly less than full-time jobs. And so you have all that stuff, it gets, and I love using things from economics because that's my field. I hate using things from economics because it gets so complicated and I know why it's complicated, and that's why I can't give you a straight answer on that, because sometimes yes, sometimes no. Yeah? Is that? Yep. Anybody else?
Okay, then you're around, so if someone gets another question later on, ask James, and thanks a lot.
Cool, thank you guys. Yeah, thank you.
glaube, es hat auch noch durchaus Strom. Geht es so schnell, dass es lädt?
Test.
Du musst es einschalten.
Test.
Aber das darf ich.
Achso, okay. Test.
Oh, richtig schön. 1, 2.
Passwort.
So. Und was musst du da jetzt machen mit dem Laptop? Weil wir haben eine Stunde Zeit bis zu den Lightning Talks und jetzt ist da Robert.
Ja, ich muss dem Robert assistieren. Ich bin ein Prop für ihn.
Alles gut?
Ja, von meiner Warte. Schauen wir mal, ob die Leute kommt wahrscheinlich noch eine Last-Minute.
Welcome with me, Robert Matzinger, who is going to talk about the virtualized lab infrastructure he built. So let's see how Fachhochschule Burgenland is doing things. Thank you. Hochschule. I never will learn that.
Yeah,
so.
That's difficult, I know. Welcome to this talk. You may know me already. I'm host here and for staff and teacher computer science and teaching in various lecture programs. And my lecture programs are structured in two groups. First I teach theory, so this is not the topic here, but also practical IT, so operating systems and Linux system administration, various programming stuff, infrastructure engineering, containers, blockchain, a lot of stuff. And I also do the infrastructure for many colleagues of teachers that need labs for several lectures. And when you think about computer labs, how you build them, how you equip them, you have two problems. The technical one, how do you configure them? And the tactical one, how do you make students learn what you want them to teach? So, and what is so often misunderstood still to nowadays, that we in IT, we don't teach with computers because that's actually everybody doing now. Despite any topic, nobody works without computers nowadays, but we do, we teach about computers, so it's the subject. And it makes very different requirements for a computer lab. We need specific configurations. We very often need root privilege because when we teach configuration of programs, you must make our students administrators of them. We have to do reliable resets. We have, sometimes we do with intentionally misconfigured computers such that configuring them right might be the subject of teaching. So, and when you look at the traditional lab, where everybody sitting behind a real computer, they are working together. The process is often more important than the result. And I see also students that theoretically know how to do it, but they just can't do it quick enough because they don't know the keyboard shortcuts, they don't know the dexterity. And I've seen students fail in exams because they would have known it, but they couldn't type it in fast enough. So I think we talk about knowledge as a skill. What we teach is skill. So it's the difference like knowing theory of harmony in music in theory or being able to play an instrument such that people like to dance to it. So this is a very different thing we teach here. So in the theory topics we teach knowledge, but now here we want to teach skill. So what was the traditional solution? Standard PCs with computer labs equipped with some software. Forget about that. I don't even want to discuss that. It's unfeasible. But Then the next solution that I observe very often is that teachers tell the students, well, please install this and that and install that and that. And that very often doesn't work right and very often causes a lot of delays. So often maybe the first 2, 3, 4 hours are just spent to keep everybody running the software that's needed. So for long ago we decided to use virtualization, and we had a system with several virtual PC images that we carefully rolled out in our lab. That project dates back to 2009, so until then we are going another path, and this is already historical. We rolled out several virtual machines in a pre-configured lab down there in the first floor, no, in the base floor, and it worked really fine with more than one PC, and you could do network configuration and everything. So having pre-configured computers for the lab was always a very good experience. But then, and when from the didactical point of view, what happened in the lab? Students were working together, and one of the and I, as a teacher, just walked around in the rows, looked them over the shoulder, and one of the most important topics is to give feedback, even when they have not asked for. So when I observe they are doing it wrong, but they're doing it in a not nice way, such that I can immediately interfere and say, well, why don't you try out this and that? Why do you choose this bad style? Why do you go into this not so well working solution? And students can discuss it with themselves, and it's a hands-on practice, and this is actually completely indispensable for teaching computer skill and not only computer knowledge. It's actually the oldest form of teaching. When you date back to the Middle Age, there were no school at all. How did people learn? Just by example. By learning from their parents or from their masters when they were doing handwork. It's just by working together they learned. So it's the oldest form. So then came COVID, and actually all the stuff could be translated to distance learning very easily, but not the lab. So what did we do? We used our old nice lab and set up in days, I must report, guacamole server. I will show you later what that exactly is, and connected together all those machines just that they were reachable from outside with a web browser. And that worked quite fine, but we could translate the learning experience we had in our lab to remote teaching. Soon we ran out of computers, so we also used the students' hardware to run virtual machines there with little glitches, and it was difficult to roll them out, it was difficult to make the computers set them up, but at least in the IT department, where we have more experienced students, it was possible to make them install, let's say, a virtual box or something like that. So, and also we set up a guacamole server, and the teacher, I will show you in a moment, as a teacher I was able to visit, to view that student computers in an instant. So what we learned to enjoy in this area of making experience, pre-installed software on a distinct computer is very fine, because we don't now have software problems, we have no compatibility issues and all that. We have to serve a wide variety of teaching scenarios, so to hurry into a session, a detailed preparation is very fine. So, for example, we prepare the browsers in those machines such that they just click to the documentation or to the right page of the course. It's no writing up a long URL, typing everyone in and like that. So it's very prepared. I'm gonna show you. So the principle was we want to solve only those problems in our lecture that are related to the subject of the lecture, and no other problems. And we call that such that the lecture can start immediately, and we call it feature click to lecture. We want to have the students come in, click one button, and lecture can start. So, and the other one that it's very important for me as a teacher to look over the shoulders of my students in these programs of teaching, such that I can find errors they make and they're not even aware of, or just bad style or not so good solutions. And when they pose questions because something does not work, I may very often see the solution before they even concluded the sentence where they asked me what the problem was. So often yeah, and it's also pacing, because when I look at them, I see how fast they find the solutions, how fast they can make the next step, and all that. So we call that feature click to student. So these are the features we wanted to have, but the solutions we had some enormous difficulties and some problems still, although they worked quite fine for a couple of years. The rollout times were long, the image sizes were enormous, and it was also an exponential explosion of numbers of machines, because this machine had a module A, module B, module C, and this had only E, A, and C, but D. And when you wanted to update such a system, it was a nightmare. So at that time came the message that also our hardware is going end of life, so we wanted to transfer this good experience into a new time where we do the technique behind that in a better way. And at the same time, the cost of cloud solutions has decreased an amount that it does make sense to just rent the particular hardware at the cloud provider. So we want to keep click to lecture, click to student, and build something flexible and modular, which we now call Villas like cloud, and that's what I'm going to present to you today. So we use infrastructure as a code principle, and wanted to have something where we also keep the knowledge in-house, so where we don't go into a dependency of some particular cloud provider that may have a wonderful solution. They don't, but anyway. But we are then dependent on exactly that provider. We wanted to have something that's relatively independent and where we have the recipes and the knowledge in-house. And secondly, we wanted to have something modular. We can say, okay, in this lecture we need module A, B, C, and the other one we need A, but not C, but D and E, and whatever. So that's what we built, and the principle is relatively simple. We built small computers for our students. Every student for every lecture gets such a small computer with its own small desktop, where everything runs what is necessary there. We built a so-called guacamole server in the middle. That's basically a translation between VNC and HTML5, and such that even both the students and the teacher can access this remote computer through this guacamole server with a simple web browser. So anyone running an up-to-date web browser can use the lab immediately. Yeah, okay, so then we rent this infrastructure as a cloud provider, and I just show you how this looks like. For an example, I go here for, let's see, try that one, I don't know what is running in there. So that's a real world example, that's not set up for you. I have a login here, and you see this is there are real students, and this is my computer, and this is a test computer. Let's see what we did there. You see, this is just the result of some real-world lecture that was going on last week. Whatever it was, not necessary. But you see the click-to-student principle. Okay, then we define all this by a script system I'm going to present. It's actually the essence of the whole system. And we only have to keep the scripts, because from the scripts we can immediately set up the whole lab in a couple of minutes, which I'm going to show. And because we have all the scripts, it's independent of a cloud provider. What is the base of the solution? OpenTofu, so the successor of Terraform. We run up the infrastructure, and then we configure it with the Ansible script in our own whole library of Ansible scripts for various lectures. What really was an annoying thing was, how do we do the account management? We have Moodle as a base platform for teaching. You most probably know. I don't know whether your institution also uses that. So I found a way to extract the attendance list of some lecture and then mill it up with a couple of scripts that really put some effort in to find out the details. So in these scripts have two outputs. One is the permission file for the guacamole, and the other is the file which I upload back to Moodle such that to public the passwords to the students. So that's how they get access. It was really annoying, so I found myself to really mess around in the hex editor to debug this, which is mainly to some minor annoying issues. But we managed to do that. Our current provider is Hetzner, so we have an European provider. We need some DNS system before, and as I said, the topology is, we set up the topology, then we create various config files, and then we install the software. So I come to the demo. You already seen the result, and I want to say to so this is a directory where I keep all those files that set up the system. There's already a lab. No, it's no, I obviously deleted it. No, it's running. Okay, so I can also show you how I delete such a lab after the lecture. So that's about it. Now all the servers get deleted and are no longer to be paid for.
Oh, I'm deleted. HMs.
Yeah. And in the meantime, while this is running, we can look into which files are necessary. So we have a topology section where you mainly define what you need for servers and so on. There's somewhere the student list. No, it's not because it was deleted. Anyway, there's a central configuration file for how this lab is built. /lab config to have, so which is the IP which is currently fixed, how many servers shall a student get, what kind of servers do we need, where is it located, and so on. Okay, so this is the topology. Then in the inventory, it's built. The inventory is built automatically. What's important is the student list. So we have the students here. The access is just that the passwords are stored elsewhere. So in this lab, we will have 5 students, and we also have the teachers, which is currently me. So this can be altered quite easily. And then very important, I go into that, is the configuration, where you have several stuff, but most important, it's the client.html. Let's look into that. Maybe we put out the comments. And you see, okay, this is some preliminary, and this is the modularization. So we need some regular stuff, and what you read here, this is how we configure this lab, particularly for Python programming. You see this points into some library. Let's look it up here, because here is all those files. So when we look into the Python client, this is just what you have seen. You have particular this Python stuff. So what is the Python stuff about? It's in lib Python all. So we need Python, we need tools, for another colleague we need Python Visual Studio, PyCharm, and Python virtual environment. So for example, what is this PyCharm? It downloads the PyCharm file, unarchives it, and then it creates a desktop entry. So that's what we need to run PyCharm on such a machine. So we can really modularize that. So when I have the lecture where I need another module, I write another client.html file and put in the right lines for putting in the right modules. What is also interesting, you see the destroy of this lab already has finished. What also is interesting that you can, for example, have such customizations of where does the URLs in the browser point to, such that you can have a particular landing page for this lecture, such that you don't have to talk about, well, please type in HTTPS, blah, 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 and everything. Everybody types it, and you need about a quarter of an hour since everybody got it, but it's just at the beginning of the lecture, hit this button and you get right there. I'm gonna show you. Okay, but what is, all this is put together in only one command, which when it's configured live is called create lab. So to see that we really do this live, lab 16 is currently empty, it doesn't work. So we have more or less resembling something like 20 lab rooms. So this lab is currently empty. I want to equip it now with the configuration you have just seen and call create lab, and it immediately starts up to define the members, as you've seen here, assign a machine to each member, set up the machines, which is happening right now. It takes a little time until it has provisioned the right servers for us. Am I too fast? No, I think. You wanted to see live demo, didn't you? Now these machines are put behind the right firewall, such that we are safe here from that point of view, but we can alter all this. I'm going to tell you about when I discuss the various scenarios of lectures. Now there are some SSH keys generated, grouping for the case that one student owns more than one machine, which is also just built into the system as a possibility. Now the SSH is tested and verified, and now it just starts the creation of the connections, such that all these access rights are given right, and now we're already into the configuration, and so this is Ansible if you know it. And you already see one of the main advantages. It's built freshly, so we don't have something like images. It's built freshly from scratch, such that we have the most modern software running. And that's a big advantage, because that was one thing we fought with before that, to update all the machines to the newest releases, patch everything. This is not at all necessary here, because a lecture usually runs for a couple of months. We can do without update, and the next lecture will be generated up from scratch with the updated versions of all the software. Okay, let it run. In the meantime, you see, okay, lab 16 does not exist currently. But in the meantime, I've set another lab to the same configuration. So let's show you this from the point of view with teaching. This is then answered.
Okay.
So wir sind im Lab 14.
So what is the URL?
Lab 14 lab 14.ditm.
Oh, 1 minute. Lab 14.
14
dot
ditm.
DATM.
DITM.
DITM.
.at.
Yeah, okay.
So you see, I'm here. I see all my students that are in this group. I have here my own computer, which looks like this. I can even make it full screen if I need to. And I've already installed a lot of stuff I need for Python programming here. So I've installed PyCharm, PyEnv, and I've even installed a virtual environment that you start into right from the beginning. So all a student has to do to So this is all it takes to start into Python programming. Okay, and we already installed various development platforms. So okay,
On Vivid, I made. I was on a Neo keyboard. So I could not make a monkey.
Okay, and the new script here. So even here, you see, there's no setup for our students, nothing like please install this and that. It's just log in the same way as we in every lecture and run into this development platform immediately. And if Horst manages to log into that, I can click to his screen just in a moment and solve any problem he might have there, because I as a teacher have access to all those teacher screens and help along with any problem that might arise. I even tend to look at crucial students' screens during the lecture on a separate screen, such that I get the pacing on how far they can come, how they are paced in the lecture, how successful they are. And what is also very nice is that even with problems, but also with very good solutions, as you see, I can project, when we're together in a real lab, I can project any student screens in a snap. So if there's a quarrel behind there, well, there's a problem, I can just discuss this problem publicly. Because there may be a lot of other people in the room that have the same problem, so I just project this screen and say, look, now this is this particular very typical problem, it's caused by this and that, and we solve it in that and that way. And students get, okay, so that's easily discussed. Or I can make something like, who is the first one who gets the solution? I have a solution. Click, and everybody can watch it. So this is really nice for this dynamics in a lecture. Now you see already Horst.
This is me moving the window.
Yeah.
I can start Python. I cannot see anything.
No, I don't think so.
Bitte Thomas, bin schon wieder auf dem. Bin schon wieder auf Neo.
It's the keyboard.
Okay, it's just the keyboard. Okay, and I can code some little things.
Yeah, whatever. So you see, we started into the lecture right away. In the meantime, okay, it's still working on the configuration, but it takes about 20 minutes to configure this lab. In the meantime, let's discuss how we achieved our requirement. You see, it's a consistent handling, and when students study with us, every lecture works the same way. So they're used to, okay, they're told you're now in lab, I say, I don't know, now 9, just click there. They are all the same in credentials, so they just know how to log in there, and now everything's gonna work right away. For us as a teachers, it's click to student as you have seen. And please, when I presented this, I was very often confronted with the notion that, well, yeah, we do have desktop sharing. This does not compare. It's not, can you please share your desktop? Yes, I can, and it costs lots of time since they do it. Now this is something I can do, and I can do it immediately with just one click from the list of students I have. As you see, we have a library of such lesson plans, so when I run the same lesson like last year, I can just take the right client YML, and it's concise, it's easy to read, it's easy to modify. When I need an additional module, I write the corresponding YML file and just include it in there. It's very detailed in the configuration. Let's show you that. You've seen that we wanted to have the Python configuration as a main landing page, and so when students go in these machines into a web browser like so, there's this main button that calls links, and it connects exactly to what we configured to be this lecture relevant main link. We even have a scratch pad, a little chat application we wrote ourselves so that people can exchange data in the lecture if they need to. We need this somewhere in some lectures. Yeah, as I said, labs are always needed with up-to-date lectures. But for the students it means there's no thing like speciality in how the lecture runs. Just log in there and you will find everything you need. And as cloud computers are cheap enough, we can run them 24/7. So homework and exercises are not a problem. From home, they just keep on working from where they have been. So self-study homework is straightforward. And we have now the experience with teaching also Python last semester. So was this one of our 2 Python teachers for beginners. Can you just report for a couple of minutes how your experience has been?
Yes, I was introduced into this lab from Robert, and I teach working students, also who already have a job, and then study here mostly during the weekend or online remotely. So I had some presence hours here, but most of the teaching was remotely done. And I was especially in the beginning very happy about the lab because the students I had were interested in programming, but they were, to my understanding, or at least my class, had not very deep knowledge, so I would not have been able to say, and now please everyone install Python, PyCharm, Matplotlib, and then some other library in the correct order on 3 different operation systems, depending on what they have. It would have just cost me an enormous amount of time, and it would be very hard to fix remotely, especially, or even online, that I would spend a lot of time with some machine from some student who would not work and would not do what I actually want to teach. And with this lab, it was very cool that actually I'm in a Linux environment. So I can on the side say, look, we don't have Matplotlib installed, but we can make some apt-get install or so, which normally would be a big hurdle because some of the guys have an Apple computer, some of them have a Windows, some have another machine. So all this headache of just coming to the teaching was blown away by this lab. And actually I pushed the students in the beginning to use the lab, but then of course I explained them, and you can also install this locally. And a colleague of mine made a fixed date when they should be able to work local, and I actually did not make any date. I said, look, try this at home if it works faster on your machine. And then I think I started in September, and around Christmas everyone said, actually we have now managed to install everything at home. So I gave them no deadline, and it worked. And it was very nice and safe feeling, I think, for teaching as well as for the students, that we always know if something does not work, if my computer broke up, if I installed something new, we can always, I just need to get a browser up running and we can do everything, the whole lesson online. So this was very comfortable from a teacher's perspective.
Thank you. Let me give a couple of examples of what we already taught. So this is not a suggestion, it's experience. It's something we already really did. So we did as you see, obvious, straightforward programming, Java, Python, PHP, SQL, JavaScript. We also run a lot of courses in web development because these are particular students that have not so much experience on their own computer. It would be totally unfeasible to require them to install a lamp stack or something like that. I think they would stop understanding right after the word install. But still they need to learn what HTML is, what JavaScript does, what CSS is, and so on. So, and it's also, we can also do plugin development for several CMSs like WordPress and Joomla. And we even can give them external access to the web browser they are handling. What they actually do is just run a local web server and direct the files they're editing to be the homepage of this web server. We can even give external access such that they can proudly present the work they have done to everyone who look. The cool homepage I just edited and so on. I'm teaching Linux system administration, and for that it's crucial that the students have root permissions, which I can give them easily because I can reset the machines if necessary. It's no problem with that. And I can really simulate. In this lecture, I set up a machine almost for every lecture separately. Like now we're doing storage, then you get some storage. Now we're doing network, then all of them get 2 machines such that they can network together. And we can even do such thing like simulating a RAID failure. So you have 2 disks, please build the RAIDs. We learn to do that, and now we fail one of the disks, and we look, did your data survive? So it's really practical, and they really like that. Even network administration, firewall administrations, and so on. This is really done. Now for the more advanced stuff, clearly you can run Docker Swarm and any kind of container engine in such a machine. So I have a lecture why I teach building a Kubernetes cluster, not using it, but building it. So every student gets 3 virtual machines that are interconnected with a local network, and now go ahead, we build a Kubernetes cluster from them. And so they really learn in depth how container orchestration is, and maybe the most advanced thing we currently teach is blockchain and smart contract programming. We put together a lab with all the students and start a local Ethereum blockchain in this lab. And then students together can work with this blockchain in the lab and do smart contract programming, and really one uses the smart contract of another, which can really simulate, not simulate, but this is no simulation, it's really a blockchain, but only limited to the lab, such that everyone does mining, and everybody earns ether, and everybody can apply smart contracts and so on. It's running, I think next week is the next lecture on this subject. Yeah. So, and that's the reason you may ask, why do I present this at a Python conference? Because I know there are lots of teacher people here that might be interested, and now for the first year we also put our Python lectures into this infrastructure you just heard. The experience was very positive. So basically you can teach. Yeah.
I want to add 5 minutes about the Python teaching later.
Okay. But there are other things possible which we benefit from a lot. In my lectures, we don't have turning in assignments anymore, because I can just visit, so when there's a certain assignment that has to be met, some configuration that has to be set like this, a program that has to be finished programming, they just do it, and then when they're finished, they finish, because I can meet this assignment in the virtual machine directly. And it's actually so time-sparing, because there's nothing like packing this project and then loading it up to somewhat, and then I download it again and unpack it, and it doesn't work right, and I have to modify, blah, and then I have to look it up, give it the right name. Anybody who is taught and evaluated assignments is going to know about that hassle. So it's, in my lectures, it's required to let this self-programmed software run in the virtual machine, and that's it. So I click there, just type run, and if it doesn't work, it's a bad note. And if it was like this, it's a good note, that's it. We even do exams with that. So we can do really practical exams. That spares us any hassle with the AI blah, because the exam in operating systems is really an operating system. Please install this and that, make it a firewall that does this and that, and make your data survive. Even in the exam, simulated a rate failure. So the exam program was, well, you have a computer, and I'm gonna tell you that some of your disks are gonna fail in, say, 30 minutes. Make your data survive. You don't know where it is, you have to find out, then build a rate from that, put your relevant data into the rate, and do it in time such that the disk failure will not hurt you. So this was really a practical lecture. So yeah, and we can also do group work and let students into student groups that work together on several lab computers to do something that they have to do as a group. Technical experience, Guacamole performs brilliantly, network load is acceptable, and it even works over mobile connection relatively fluent, so we didn't have any problems here. This is how it looks like when I do it from home. So it's nice if you have a good infrastructure on that. So the practice is really, so this is the layout maybe, so this is my machine where I do the teaching. All the students can see my machine read only in the lab. This is the video conferencing tool. I have quite some students that I permanently screen. You know, after some times you will know the usual suspects that you have to monitor, isn't it like that? Then I have the student list here, maybe here my cheat sheets, and that's how a lecture is done. And it's uniformly done in distance learning, and do it as more or less the same way when we do it live here. So there's no difference between distance learning and so on. So as a result, so maybe you talk about the result, and it's no difference between distance learning and in-person lectures. You wanted to say something here.
Can you show my lab again?
Yeah, clearly I can.
So a part of all of this was, Robert was telling, I want to tell from the perspective of a Python teacher. And maybe if one of you had the experience, I show Python to a friend or to a child or so, you usually start with the turtle module. And what I noticed is Robert is not the first one who has the idea that actually we can teach coding in a web browser, more or less. Yeah? And there are several tools who try to emulate Python inside some JavaScript site. But what I found out painfully is that most of them do not really Python, even if they manage to make some turtle graphics crawling around in a subset of your browser window. It's usually a subset of Python that is interpreted correctly, but it's not real Python. You can test this very easily. You know, for example, that the for loop in Python has a else clause. And this is usually not translated correctly in all these JavaScript emulations. And the nice thing of his lab is that this is a real Linux machine, and I can do real stuff on it, like here these circles with the turtle. This is not something that emulates something in another language. It's real Python that is executed in a real graphic screen, and only then this full result is transported back in the browser window. Of course, this means it's not super ideal if you want to make fast game programming or something where you need low latency, but for teaching it's more than sufficient, and it's very cool to have to teach the real thing and not something that fakes Python, but you really teach the real Python and can combine it with some third-party libraries or Linux tools.
Thank you. Yeah, this is the toolbox, quite a lot of the realized lab, but let's take some minutes to speak about meta-didactics, I call it, because I think that's often underestimated when teaching, are the unspoken messages. So the unspoken message to my students is, we use what we teach. because they enjoy the lab, and that's really what they do. I show you later on. They see that that's a solution we as a teaching team stand for. So what we actually tell them, yeah, we create solutions do you enjoy. So if you get the knowledge we have, you will be able to do the same. And that's very motivating. So they are listening. They see, okay, that really leads to something that's usable, and maybe the students can use this knowledge later on, because that's what we actually want to have. We want to have students that create startups that are creative, that actually run Europeans' IT, more or less. Yeah? So that's a very good and important influence to any lecture when you use that. For those who can speak German, these I cannot translate that. There's a comments from evaluations about the lab, so there were really many positive comments from my students. I give you a couple of, I don't know, maybe we'll translate under one of some of them. So the environment is wonderful and professional. I'm not a good translator. So I got really many positive evaluations from that. In particular in COVID times, it was students were really happy to have that because it's really from the quality of teaching. It's really no comparison to what most institutions did, to just set out assignments and then collect them and then give some feedback, because this immediate feedback is looking over the shoulders, looking to the fingers, is, to my opinion, crucial for practical IT teaching. And the lessons are obvious open source rules, because that's what allows us to adapt quickly and to build the solutions we really want to have, not to be dependent on something some big company dares to offer. Virtualization rules, as you see, and particularly localized knowledge rules, because without the local expertise, such a solution would not have been possible. So we don't want to outsource this, because when we have the knowledge locally, we can adapt to any requirements that this happens to come up. The Wheelers Lab works, as you have seen, but there's to look up the amount it has currently, so we run it in about 5 lecture programs, bachelor and master, in about 20 lectures per semester. I serve about 10 teachers with about 400 student seats per semester. So this is really some amount that has to be served, and it can only be served flawlessly when you have really a schema that you run it. There's a lot of things to do. In particular, the website has to be rebuilt. I know about that. I'm sorry I didn't manage before the conference. We want to adapt it also such that we not rely on Hetzner, because actually that must be just very minor adaptations to get to another cloud provider. So if you want to try it out, reach out to me, and if you want to help, I would be very happy to find some, because there's only the team of developers is very limited. It's me. So a lot of things are missing, but still it works, and we have managed to serve this amount of lecture programs in this way. And I hope you saw that it's beneficial, and it's nice to have heard the experience of that. Thank you for listening. Thank you for watching, and please recommend if you like it.
Questions, anybody?
Hello, thanks for the presentation. One question that I have is not really technical, but did you have any students that tried to abuse the system by using root access or some other shenanigans that you found out during the development and the usage of the system?
I must say it would be easily possible to misuse the system, because we give out the root permissions to the students. It's required for system administration and so on, but until now we didn't have any such problems. And if so, the solution would be, yeah, we had some inquiry by Hetzner. It turned out that this was wrong. We didn't anything. It was just a misinterpretation of our traffic. But still, I could react immediately because I just closed down these machines.
Okay, so you did not have any such cases, but you have some backup plans and some basically instructions. Yeah.
From where it comes from, and it's the responsibility of the respective student to avoid this.
Okay, thank you.
It was just a quick question. I really like this idea, and I think it's something that I could use going forward. How long do the machines tend to live for before you kill them off? Because I noticed that you said you would destroy at the end.
Actually, they run mostly around the whole semester, and then they may have some time where they work on assignments or maybe to prepare for the exam, and after the exam we kill the machines.
Okay. Because at the beginning you mentioned that it was just for the lecture, but it depends on it.
For example, like a programming lecture, we let it run for the whole semester. For the operating system lecture, I tell them in advance, please be aware that the machines are going to change maybe every week, such that I set up a specialized machine for the next lecture that has actually that simulated virtualized hardware I need for the next lecture. So it depends on the lecture, but normally it's a whole semester. Only in specialized lectures we change the configuration for the next day or something like that.
Cool.
Which is not a problem because I didn't conclude the demo, which is now ready because you see the lab was set up, and to demonstrate that this is not fake, let's just visit lab 16 again. You see, login. And that was it. Now the Python course can start.
Yeah, really cool. Can you add students during the...
Yes, I can add students. Currently I have difficulty to lead students because this is implementation issue we're going to solve.
Very cool, thank you. Thanks.
Hey, nice talk. Great presentation, great demo. So I have two questions. One question is, are you also sharing resources of the GPU through those virtual machines, or are you only limited to the CPU? I'm mainly asking this because, like, if the GPU is also available, you can also teach computer graphics lectures, also maybe AI programming. So I'm curious about this. And
I think we don't share anything. We rent hardware from
Hetzner.
And this is feasible because we are just renting the cheapest machine they offer, such that this is financially feasible for us.
Okay.
But we could do anything. So if it's necessary and if there's enough money available, we could rent any other machine program also. But problem with that, an unsolved problem is that 3D graphics is not working properly in this visualization. But for 99% of our lectures, we don't need that.
Okay. And one more question, if I may. So I saw your stack is basically, of course, open source, like Terraform and Symbol. But what I'm also wondering, have you tried using NixOS for the same thing? Or you're not aware of it? Oh, okay. It's basically what you implemented. It's already given there. Basically, the reproducible systems, like you had the client YAML file. Basically, NixOS is based on Nix language, which is kind of exactly that. It's just kind of.
Please give me the reference.
Yes, I will. Okay. Thank you very much.
These are the people running around with the T-shirt, never run a changing system. That's the NixOS people, right? I just wanted to comment on that. It's certainly possible to do something. You can get machines from Hetzner where you have a graphics card inside, but you have no connection, so you can't teach computer graphics using that card. But you can, of course, use AI with it. That's the main reason why they have it. Yeah.
But such a machine is not 5 euros per month, it's more 500 euros per month.
Yeah.
So,
depending on the...
Our AI department does a lecture in AI. We have a AI master's course, and they're doing this the way that they rented one strong AI server and grouped such a lab around it such that all the students has a pre-configured access to this single AI lab server, such that the cheap and easy servers are just used for the interface work with this server. So it's grouped around this big server, and that's how we do it. And they did the AI server, and I just created a lab that has a pre-configured connection to that server, so that we don't have to deal with credentials and that stuff. So we all have those click to lecture, even in AI, with one of those AI servers. So that's yeah, I should add this to the lecture list. I forgot, you're right. It was just a couple of weeks ago.
More questions, anybody?
Thank you again. I just wanted to ask about the UI that you had, because I saw you have to log in. You have to log in with your credentials, but you see every computer. How does it look like for a student? Can he access also any computer? Can he access yours?
No. Only me can access all the computers. As a student, you only see your own computer and a read-only connection with the teacher's computer.
Okay. No, okay. Oh, it does make more sense.
The list of students is only 2 people, use yourself and the teacher.
Okay.
And the teacher connection is read-only.
Okay, that makes much more sense, because I thought maybe, because you mentioned also the look over the shoulder, maybe you could have just looked at another student's desktop, that's why. But thank you.
Thanks. We have to stop. The next session starts where we have lightning talks. Thanks again, Robert.
Bernd.
Wie das Brot.
Bernd das Brot, ja.
Been integrated. Okay, where's the list of people who are...
Now I can actually introduce you.
Yeah, or I can take a picture.
He's the first, so...
Okay.
Get the list as well.
Okay. Sounds good.
Hallo, hallo. Das ganze Tafel herkriegen, können die Leute jetzt noch drauf. Ach so. Legen wir es einfach aus. Genau. So, hello, my name is Horst. I'm one of the organizers of this PyCon, and I have the pleasure to announce the host of this lightning talk session. This is James, who made this very fantastic, very emotional, and very unforgettable last year. That's why we now forced him to do it again. And as I'm the first lightning talk speaker, I cannot good moderate myself. Just here some technical information. At 6 o'clock starts the party in the cafeteria. So everyone who has a blue wristband has a flat rate and can drink and eat as much as they can manage. And everyone else, please go to the reception desk and get a flat rate wristband, or you must pay every beer individually, which spoils the fun. Okay, yeah. I think James will explain you what lightning talks are and how they work exactly. Please, Bernd, can you stand up? Bernd volunteered 1 minute ago to be the lightning talk log. The whole point of the lightning talk is that it's only, the maximum duration is 5 minutes, and Bernd will make sure that nobody can speak longer. Whatever they want to have to say, then they must continue saying it at the party. Okay, and please, here is a pen, yes, and here is our audience, yes, and here is the lightning talk list, and we have a moderator. If, and this is the typical lightning talk experience, if you think, actually, I can do better than that, yes, then go forward while the talks are running and write your lightning talk topic on this list, and the moderator will then give you the chance to have your 5 minutes of fame. Yeah? With that, I give over to the moderation.
All right. Hey guys, I'm James, for those of y'all who don't know me, and I will be moderating these lightning talks. The thing about lightning talks is they are 5 minutes. It is a firm 5 minutes. Let's give Barrett a big round of applause. We will be stopping at 6. If you have an idea, I think we have 3.5 talks left. Feel free. Our first talk is Horst. Let's give Horst a big round of applause.
Okay, this lightning talk is without any slides because I was busy playing with my son and had no time to prepare slides. The lightning talk is directly out of my heart. He lives there since many, many years, and I never understood actually what I want to say, but in the last hours I could formalize it. So I have a dream, and this dream is to have a FLOSS magazine, FLOSS for free, libre, open source software. If you know about Richard Stallman, then actually in this direction. And why magazine? Because when I was young, I loved to find a big staple of computer magazines and read them. This was for me more interesting than things like learning or studying or working or other people. I liked to dig into these magazines. And I think now that I'm a father, I think it's important to give young people the chance to actually develop their view in the world and their wisdom and their ideas, and in an interesting way. And what I, like we have here Fiona and I think Gregor from the Free Software Foundation, what I think the problem is when you speak to computer programmers, usually the guys who are interested in free software, open source, they already know about it and you don't need to convince them. But those who don't know about them are usually the young ones, usually the ones who are not very deep, who are just Windows users or know a little bit programming. And I think for them to make a very good magazine with interesting stories, with interesting examples from real life, with some programming courses, with some comics, with whatever, and make it under the free Creative Commons share alike license so that every student can make his own magazine out of this, or his podcast, or his business idea, or whatever. This would be a worthwhile doing. It would be something that I would be proud of to make. And if you like such an idea, please join me in the party and have a beer and let's talk about it. Thank you.
Okay, there's an Ivan or an Yvonne who doesn't have a topic, wants to know if that's or what's the problem. 5 minutes starts now.
So, hello to everyone, I'm Ivan, and my topic is I have no topic and that's the problem, or what's the problem? So, since we're here at the conference and I see around like 50, 70-ish people, and each and every one of you has at least some relation to Python. So, some of you decided to start coding in this language relatively like a few days ago, a few months ago. Some of you have spent a better part of a decade, 2 decades, of half a century. No, actually less. Whatever. And my point that I wanted to drive is each and every one of you has some interesting stories. And the unfortunate reality of this is not everyone is able or can present those stories due to certain reasons. So the first point that I wanted to drive is the I have no topic, what's the problem? Some of you just figure that this is not a topic that I'm confident enough to present something. And for that, as a person who spent a better part of my life trying to express myself with words at presentations, at scientific meetups, there is no person that knows more than something that you're passionate in. For example, I'm passionate in speaking. That's why I'm speaking right now. Some people are passionate about specifics of parallelizing and multi-threading and some other stuff. Some people are passionate about async and they follow this since the inception. Speak about it. Everyone here came to learn something new about Python, and you should pursue that. If you want to speak something, speak about it. And the second point is I have no topic, and that's the problem. That also cannot be. When you are working with Python, when you're working with basically anything, you are investing yourself in it. You learn something more, you learn something new about it, each and every iteration that you work with it. So if there is something that you are interested in besides, well, living, you are able to speak about it. And everyone else, or at least some of them, I certainly hope so that at least some of you are interested in what I'm speaking about, they will listen to you and they will reflect on it and they will say, hey, that sounds like a good idea, or hey, that sounds like a bad idea. It doesn't matter what they think, because at the end of the day, they thought about what you said. You have made some changes to some other people, you have influenced their life, you have shared your own experience, and in my purview, this is something that everyone should do, and this is one of the biggest parts of life, to share your own experience with others. I don't know about time, but I thank you for your attention, and thank you once again.
Okay, does that make you Benoit? Yeah. All right, round of applause for Benoit, guys.
May I plug or no? With a screen or not? No screen?
Yeah.
With no screen, I can.
There's a screen around here somewhere. Yeah, I saw it earlier.
Maybe.
That might work. This does count as part of your 5 minutes. So right, you're already on time, right? No. Oh yeah. Yeah.
Thank you.
Talks and food setup. Let this be a lesson to you all for tomorrow when you sign up for your lightning talk.
Seems to work. Okay.
All right.
Okay. Demo effect. Yeah.
Sorry, I don't make the rules.
Yeah.
Just follow the orders.
Nothing works anymore. Just take my mouse. Okay. Okay. That will be a very short presentation, I'm afraid.
Is this like you talk about creating new desktops?
Yeah.
According to the sheet, it's new words in a foreign language. And
Yeah.
if anybody needs that, that's me. I'm
Yeah.
really hoping that this all starts cooperating real fast.
That's great.
Okay. Is that Horst's time is now finished? I don't know.
That's a lightning talk on display issues.
What do you want to talk about?
Yeah, but I need to display. Well, yeah, I can start talking while trying to display on my own computer. So I have been working on a project about learning new vocabulary, new words in a foreign language. I am French. My name is Ben, and I've been studying sometimes in Germany, and of course everything in German. And I figured out that I had to learn a lot of new words that I couldn't retain in my head. So I tried to build first a VBA macro on Excel to train and trying to keep all these words in my own memory, so I can use them in a daily conversations. But it happens to be not enough, and I figured out if I can do this on VBA and Excel, why should I should try at least to do that with a Python and modern tools. So what I like to try to show you is both the architecture of the application and how it looks. And I'm afraid I'm going to spend the whole session. Sorry? Can you just describe it? Yeah, it's really cool. Thank you very much. It wants to. I have four displays, but anyway. Okay, and the idea is a bit like who uses Duolingo, for instance? Okay, so the idea of my application is a bit like Duolingo, but thank you very much.
Terribly sorry, but
yeah, it's okay.
Yeah, find this afterwards. Happy to see more. Now we have a Chuck. Chuck. Where is she? Saw her earlier. Pandas going to win as polars going extinct. Yeah, right? It's I saw her earlier. I don't see her now. Is she? That's not you. Are you Arnold? Yeah. And you're getting ready just because she does this. Yeah. I tell you what, I will move her to the back. You can go ahead and start coming on up if you want. Sure. Because she's still not here, right? Going once, going twice. Okay, so we have Arnold. Is that XL Wings Light?
Yes, it is XL Wings Light. Let's see if
go for it.
This connection works.
Yeah. Guys, Arnold.
So, animation, so slideshow from beginning, and there is no slideshow. Very nice. Apparently, but I'm talking about XL Wings, and I'm talking about my experiences with a free-to-use Python add-on for Microsoft Excel. And the first question here is, does anyone else need Excel for their daily work with Python in combination? No one? Okay. Then, why do I use Microsoft Excel for work? I'm a game mathematician for casino slot games, and you know probably the casino slot games, if there are 3 aces symbol in a row, you get some money back. And if there are some special symbols, you get some bonus game and you get a lot of money back. But the casino wants from us, yeah, we should only pay out, for instance, 95% of the money that the player puts into the machine, because the casino wants to make a profit. And the calculations within Microsoft Excel are usually done with Excel formulas if they are very easy to do. So some product, some if or so. Then more complex calculations are usually done with Visual Basic for applications. And it's, in my opinion, outdated. And the disadvantages are that they are limited in comparison to Python. And everybody is used to code in Python when you come from university, and almost no one is used to code in Visual Basic for applications. And the most complex calculations are external scripts that can be Python, that can be Rust, whatever. And the disadvantage for that are there are external files. We have to setting up a virtual environment or so for if someone else wants to use it. There are slow connections with Excel and so on. And so we want to use Python within Excel. But there is a Python in Excel with the Microsoft Python in Excel runs in Microsoft Azure Cloud. And whenever you run a Python cell, it sends the content of the workbook to the cloud, runs it there, and sends the result back to Excel. And that's not what we want. We want to make that locally. And other Python add-ons that the one I want to present you are not free to use, and at least not for professional usage. And the solution is XL-Wings Lite, and that's free to use. It runs entirely on the end user's machine without sending any data out. Then I wanted to share some pictures, but that's apparently not possible. But the experience of myself using it, it's almost all computations are very fast, which can be a problem, which a lot of my colleagues thought that this would be a problem with XL-Wings Lite. And all is in one file. No need to set up a new virtual environment on a new PC. And almost all Python packages can be used. But there are also disadvantages, like writing data is a lot slower than for Visual Basic for applications. Writing anything other than data is not recommended, like setting styles within Excel. And it's not as nice as using an IDE for developing, because it's really inside Excel, there you have your scripts. Yeah, thank you. Do you have questions? No questions? Okay. Thank you.
Thank you for being flexible with our use.
Sure.
It really makes me miss Windows 95, right? Then we are at, I didn't miss anybody. Brandon, what McDonald's can teach us about software engineering. I missed this, Brandon. Nice. Cool. Let's give Brandon a round of applause.
Cool. We'll see if I'm lucky enough to have this work, and no. Oh well, whatever. I had 76 slides, it's cool. And that's not actually a joke. My talk is what McDonald's can help teach us about software engineering, or the only cultural contribution to society my country has. The first year McDonald's was founded was in 1948. Originally, they didn't have French fries on their menu. That was a quiz, but there's no answers, so it's okay. You can trust me that I know this because I've rated over 90 different McDonald's characters, as you can see here, into a tier chart. A very brief history of McDonald's. They were founded in 1948 by the McDonald's brothers as a drive-in in San Bernardino, California, with their key advantages being they were very quick and very efficient. One of their main innovations early on was what was called the speedy delivery system, which required a complete overhaul of kitchens and was relatively new for the time. Specific tasks were assigned to specific workers. Someone would make French fries, someone would make hamburgers, someone would literally just chop lettuce all day. That level of specialization made them have to hire 12 people at a time, but let them shift things into a world where they could produce food with minimal wait time. Ultimately, going forward, this would be something that would help them become the restaurant that they are now, where they can easily scale up quickly. Eventually, Ray Kroc came in, there's a whole movie about this, and decided to help franchise them and grow them out, which furthered the need for that system. This has taught us a few lessons that are useful for software engineering. Don't be afraid to approach old problems in new ways. There are existing solutions in software, but we can probably do things better if we try them again. Caching things and doing them ahead of time can be really helpful. Microservices and specialization can lead to more efficient systems for both work and development. Having one system that solely takes care of users and data around that will help you maintain all of that there, and you can build stuff faster without worrying about it being too big. And lastly, customer education is key. Cool. Next thing, eventually Ray Kroc stepped in and built out what was called the Sonneborn model with a man named Harry Sonneborn. This had McDonald's corporate buy out specific land and then lease the franchisee franchisee rights for that area to different people in the land. So they were able to effectively double count revenue from both land ownership as well as revenue from leasing their brand and food sales to companies, which today is responsible for $37.7 billion US on McDonald's balance sheet, 99% of their assets, and 35% of their gross revenue. This has been something that's widely been considered one of the dominating reasons they're as big as they are. In 1963, as they continued to expand, they introduced Ronald McDonald, the lovable hamburger clown, who was played by Willard Scott originally. He's kind of scary here. He went to the moon, can multiply hamburgers, generally pretty terrifying. Things you can learn from this. Make products that inspire joy and they'll resonate with people. It will continue to grow. What was once cool and fun might be weird and creepy 60 years later, but don't worry about that. And how you promote a product is key to building out popularity around it. You know, if you're building open source libraries, go to conferences and talk about them. It'll be something that'll help you find customers and people who want to use them. Where am I at on time? Okay, cool. Eventually they decided to replace Willard Scott. They've created a whole series of characters here, Grimace, Birdie, etc. I'm going to skip these slides because they're all visual. And yeah, they copied them off of a TV show that was airing at the time, HR Puffin Stuff, and eventually got sued for it. Yeah, lessons learned from that. Just because it works for someone else doesn't mean it's going to be the best solution for your problem. You should definitely innovate on them and continue to make them work. What you make together as a team is going to be better than each individual component. You know, advertisements like that don't work just because one character is popular. You need multiple. And then if something doesn't work, don't be afraid to kill it off too quickly. You know, it's only time. You'll build something better. Cool. Thanks.
Try to set it up, we'll just take it out in 5 minutes.
Okay, I will keep yapping, I guess. But sorry about being fashionably late, and thank you for my hot take. I do have that in my bag, if you know, let me know before. So, wait, give me 5 seconds. You never see me running so fast before, actually. Yeah, so you give me, where's the HDMI thing again? Can you help me to find it? Where was it? Someone showed me before. Oh, yeah, thanks.
That's the one.
Right, thanks. I also make you run very fast for me. Thank you. So it still doesn't work. Okay. Oh, it's working. Okay. It's going. Okay, by the way, I can leave this here until tonight, so if you are giving a lightning talk, then yeah, just make sure you return it to me. Right, so hot take, panda's going to win as polar's going extinct. I'm going to prove it, and I think you'll walk out this room believing me. Because we all love pandas, right? They're very cute. They're vegan, they eat bamboo mostly, and they're very clumsy. You have seen like those kind of Instagram video that they're like rolling off from the swing and all this, like super cute. And also, it has been used by China as a panda diplomacy. So they send out these pandas to different zoos around the world as a, friendly gesture. So, and because of us loving pandas so much, pandas number is usually quite small. When I was, studying in school, we are told that pandas are endangered species. And however, good news, from 2004 to 2014, the wild population of pandas have increased 17%, and the captive population, because China have this smart idea of like, I don't know if you have heard about it, because pandas' mama, when they give birth, they would give twins all the time, but they will only raise one because, I don't know, pandas' mama like, I have enough, just raise one. So the conservation thing in China, they are like, oh, we'll raise the orphan, right? So they have doubled the population of pandas in captive. So they are no longer extinct. So in 2021, they announced that like they are no longer endangered species. However, it's not such a good news for polar bears, or polars, simply. Because of global warming, you may have seen those Instagram reels of like, polar bears was like swimming, they can't find an iceberg to climb up and rest. So they have to keep swimming. They're super thin because climate change forced them to maybe hunt somewhere that they are not traditionally used to be. So it's also estimated by 2050, we only have like, it will shrink by 2/3, the polar population. So to conserve, to protect them, one of the things that you could do is to, we have to do better in climate change. We're trying to reduce, reduce greenhouse gases and also, protect their habitat. Now, since polar bears are forced to, hunt further down south, sometimes they will create these like human and polar bear conflicts. And, to stop doing that, we have to really, be more smart about how to mitigate climate change. So both animals deserve to be protected. They're both very cute. I love both of them. So let's do our best to save them. Thank you.
Nice. Next I have Ming. Yeah. Cool, and it is leverage your data for more effectively with, reading is hard.
Thank you, everyone. Thank you. I actually also had slides, but I'm too scared to even try to put them up there, so I'm going to just talk to you straight up. My name is Ming. I'm here to talk a little bit about docking today. So for those of you that work in tech, presumably a lot of you are either working in tech or in school for tech, you have likely already leveraged AI or built AI in some capacity or used AI in applications. The issue with AI is that we are slowly running to a point where we do not have enough data, or at least our data is no longer good enough to continue improving on our AI applications, to continue improving on our AI models. You'll ask, how do I have experience with this? Well, the majority of my career has been spent on training LLMs and building LLM applications. You might also be thinking, well, this guy's pretty young. What is he talking about? Like, how much of a career could he possibly have? Technically speaking, 100% of my career has been spent on building AI and building AI applications. So technically, I have a little bit of expertise in the space. I've only been in the space for technically 3 years, so I'm not gonna, say that I'm a professional there. But when I was building AI applications, when I was building and training LLM models, the thing that we noticed the most was that data was slowly becoming less and less valuable, right? The data that we had was becoming less and less valuable because our methods of actually extracting data from data was less valuable, right? A lot of data needs to be in forms such as Markdown, HTML, or JSON, these more common forms for model training and model inferencing. The issue is the majority of data that organizations have was never meant for machine understanding, right? All of them were built to specifically be for human understanding. PDFs specifically were built to be printed, right? It's just a collection of coordinates and characters and where those characters should be in a page. Of course, now that we've moved to an era of AI and everyone wants to be able to leverage their data in model training and model inferencing applications, we need tools to convert that data from human understanding and from print understanding into machine understandable formats, right? So Docking is an open source Python library. It's specifically designed to help you convert from those formats into, allow you to export into Markdown, HTML, or JSON formats. It actually has a unique Docking document representation of data, which is a very highly structured hierarchical representation of data which preserves all the parent and child relationships within a document. It preserves the table structures within documents. It preserves images. It preserves figures. It preserves captions in relation to those images. All of this structure is preserved within the docking document and then allows for these more complex exports. It also allows for chunking, advanced chunking features. It allows for formula figure recognition. All of these complex features that you can then enable based on very metadata heavy document representation. Now, the other issue with that is that even though we can now go from formats that are considered human readable to machine readable, we now want to go from formats that are machine readable to more AI ready, right? So the issue with some of these machine readable formats that we leverage now, including HTML, including JSON, is that they're very verbose in their representation. They use up a lot of tokens, and they weren't actually created with the idea of model inferencing in mind, right? They have a lot of tokens represent the same structure. What the docking project has also introduced, and sorry, I forgot to mention this, is an open source and MIT 2 license project. What this project has also introduced is a new doc tags representation of data. So it's an OTSL-based data representation format, which means that compared to HTML, representing the exact same structure actually saves you around 40% of the tokens, right? So our goal from this doc tags representation is to push for a more standardized data representation format, or an ISO standard of data representation, which means that as models are then trained to recognize this format and also trained on this data format, we can then save total inferencing costs across the board when we start feeding different queries and different data into models. I think that's basically it for docking. Feel free to look it up. It's on GitHub. It's a very popular project on GitHub, over 50,000 stars now. If you just look up dockling on Google, it should be the very first result. We have a bunch of workshops and practice things that you can try out. But thank you very much.
Okay, next we have Christian the nice guy. Or nice guy. By the way, dockling, D-O-C-L-I-N-G. No K. Is that right? Yes. And does the duck just have to be there? No, it can't. No. Don't Google dockling emoji. No. Okay, good to know. All right, Christian.
So I have created a fast API application. I'm not going to talk about it today because I think the framework is quite popular. But now, since I have this service, I wanted to have a front end for it. But I'm a back-end Python developer and I have no clue about CSS and JavaScript. So how can I make a nice front end which doesn't look like the 90s? So I found a nice guy, and it basically does all that for you. You just write Python and it creates JavaScript and CSS and makes it look nicely. So like you can easily create a table, or where you can type something, or even the fancy things, or what I like, where is it? Here. You can have a date picker, and you just need to write this kind of simple code, and that's all what needs to be done, and you can just create a nice looking application with only using Python. If you really want to, you can also add CSS for the more complex cases, but it's looking nice. Easy. Thank you.
Fiona, I think you're next. It looks like we have time for 2, maybe 3 more talks if somebody has something burning in them. Otherwise, I will give a talk. You guys don't want that. It won't make any sense. Everybody has a talk. We established that, right? All right, Fiona.
I just wanted to briefly talk about the Fediverse. What is Fediverse? It's a combination of federated and universe. And what it is all about, it's social media, but it's actually social again. And I mean, lots of people are using social media every day, and many people are unhappy with the big platforms. There's a lot of ads, there's the algorithms who push content, which generates clicks and might not be the thing that people actually want to see. And there's a lot of manipulation as well, and also political. And the Fediverse is an alternative to that. It's based on the idea that we can have an open protocol, and there can be different services and different instances that all speak the same protocol, just like with email, and then we can all interact with each other. So there's an alternative to Twitter X, it's called Mastodon. There's an alternative to Instagram, it's called PixelFed. There's an alternative to TikTok, it's called Loops. And they all have their own UI, they are tailored towards different use cases, but they all still speak the same protocol. So if you make an account on Mastodon, you can still interact with all the other services. The protocol is called the ActivityPub protocol, and there's also the AT proto, which is used by Blue Sky. You might have heard about Blue Sky. It's also an alternative to Twitter. It's a different protocol. It follows the same idea, but de facto, Blue Sky is rather centralized still. A few days ago, there was an outage, and even other instances didn't actually, users couldn't even log in, even though only the main instance was down. So it doesn't seem quite ready yet. The ActivityPub is much more widespread. There's instances in different countries, different organizations, associations, also volunteers, communities run their own instance. And you can just register anywhere, and you're in control. You choose who to follow. You will only see the posts from those people, and that makes it a bit harder to get into it, because you don't get that many recommendations. You have to search for them actively, but you also only get the content you actually chose to see. And yes, that's what I wanted to say.
I don't trust the J anymore. I tried to learn Spanish, now I'm learning German. Is it Marcel, John, Jan, Jean?
Jan, Marcel.
Marcel Jan. All right, Marcel Jan.
Hi, I'm Marcel Jan. I'm a data engineer, and I get a lot of data sets of varying data quality. And a while ago, I was working on a course, making a course about data management in practice. I mean, there's a lot of data management, what you should do, but I actually wanted to show data engineers, this is what you do, how you do it. So one of them was, of course, about data quality, but I was thinking I get to look at these data profiling tools. So I was looking at a tool called Y data profiling, and Y spelled as the Americans spell the letter Y. It's I tried it out on, I had a data set lying around with Olympic athletes from the first modern Olympic Games to, I think, 2012. And I ran it, and it created a beautiful HTML report, and it showed more and more per year of Olympics, more athletes are attending, and then some other things. And then I scrolled a bit down, and I saw the what do you call it? The histogram for age. And it has also nice statistics, like the youngest athletes attending, I think, was something like 9 or 10 years. And then I looked at the other side of the spectrum, and I saw 97 years. And I was thinking, there's no way that an Olympic athlete of 97 years attended on the Olympics. That's no way, that's not possible. So dug a little bit deeper and found out that there was some data quality issue indeed. And from that moment I was thinking, I got to run this on everything, on all the data sets I have to work with, I want to see. And this I did. So currently I have, for example, a data set from a current customer with the kilometer. When you go to a fuel station, you need to use their pass, and you need to put in the amount of kilometers on your car, and just like I expected, most people enter 0 for like something like 60%. So just running that little Python package, Y data profiling, Y data hyphen profiling, look it up. It's really nice. It shows wonderful report, a wonderful HTML report, everything like all the statistics per column, per data set. It gives you alerts. So have a look, try it out. That's my story.
Thank you. You guys are really serious about this lightning talk. Poor Baron has barely done anything. All right, is that Franz?
Yeah.
Yeah. There you are. It's Teach Software Engineering. It's Franz, guys.
Hello, good afternoon. It was a lightning talk, so it struck me like a lightning to talk. We heard even before, he told us talk about what matters, and I want to teach about what matters. It's just a small advertisement session. I'm teacher here, university teacher here at the University of Applied Sciences, actually in the field of software engineering, and we are hiring. So if you're keen to speak about what you really like, what you're fascinated about, and if this is in the field of software development, software engineering, IT, and the whole field, then please apply. What can we offer? Yeah, there are lots of benefits in our job, and what I currently most like is that I can extend my Erasmus experience to study abroad. I can now extend this into my professional life. So I was in Switzerland 4 times. I will go to Croatia this summer, and so this is one of the benefits we can offer, which you won't find in a traditional 9-to-5 job in a company. You have to, so you can teach younger people. I think this is a good opportunity to stay young for myself, and I can work in the field that I really like, which is software development. And so if you have same feelings about sharing your experience with others, this would also be a possibility. And especially I'm currently looking for speakers also speaking or teaching in English language, as they don't speak German language. So get in contact with me. Have a nice afternoon.
Okay, we still have a pin. We have no more names. Yeah, go for it. What's your name?
Gabor.
Let's go with Gabe. Gabe. Gabor. Ah, yeah, you're Gabor. Okay. Big round of applause for Gabor, guys.
Is it functioning or should I wait my turn?
You know,
maybe it's parity based.
We'll see. Give it a shot.
All right. Which one do I plug in?
Yes, again, don't find it.
Is it? I would use this one.
You already have the converter. Awesome.
Yeah.
Heard quite a few reasons from you during the talks to do things like you're passionate about developing. That's great. You want to solve a real world problem. Also, some of you even mentioned you want to make some money. But have you ever developed something just to piss somebody off? Raise your hand, please. Just be honest. There you go. Thank you. Thank you. New York Times used to have this digit game. It's very popular. I even heard that there was a British TV show with the same theme. So basically you're given 6 numbers, and you have to use elementary operations to reuse 6 to 5, 5 to 4, and so on and so forth. And you need to get as close to the final solution, which is the target number, in this case 73, as possible. I had a good friend, and he was a little bit bad. And I tried to be like very nice with him, but 7 years of engineering makes you obnoxious. So I was like, every time I hear something that people tend to do manually, it could be automated, I'm like, why are you doing that? You could just write a script for it. He didn't believe that, so of course, challenge accepted. I cannot play this, also that was part of it. And I would like to make this kind of a motivational speech to just make sure that, yes, whatever you're developing is way more useful than what I did here. So I decided, okay, let's write maybe just a tiny script. How would you solve this problem? You didn't have to do this reduction, it's kind of a root for solution. And to be honest, the logic behind that is something that you can find in most lethal challenges. It's just a multi-slate problem that you're resolving slates and reusing the problem. So let's take a look at it, and I would like to promote that a little bit. Again, if you know how to solve that, just great, I have no idea. What I know is how to make it automated. So for that I created a package that you can basically just install, and it will tell you all the steps so you don't have to do it. Let's see if it still works. It did like 5 minutes ago, but you can never know. So yeah, yes, if you want to generate 1, 2, 3, 6, I could do that, but let's follow the guide. I believe 1 + 2 = 3, and 3 + 3 = 6. Awesome. Moment of truth, I still have like 1 minute, right? And we have to be cautious of the runtime. Okay, there we go. Let's see if we can make use of that. If I'm reading it correctly, our first step should be adding 6 + 7 = 13. Next one should be, help me out please, because I'm drawing blank. Maybe creating 10 + 11, 21, thank you. And then moving on to one more step, 12 + 13 = 25, and a multiplication, no, it's actually a difference, the last one that you can do. The game is no longer New York Times. Cancelled it in 2023 for no obvious reason, because that was super popular. I would love to play back something to do with that, most probably no. But anyway, if you feel like playing along with that and just tinkering with it, just go for it and install it. Thank you for your attention.
All right, we got 10 more minutes. Who's next? Yeah. Yeah. Vinayak, guys.
Oh yeah.
Doesn't see anything yet. Yeah, that's good.
That's good.
Takes a while. Yeah.
All right. How many of you like conferences? How many of you like a terminal? Using a terminal? A lot. So you're gonna probably like what I'm about to show you. It's called Conference Radar, and it's a CLI tool that you can use to list all the conferences happening all over the world in your terminal. I can show you how it works. We open a new terminal. It's showing me all the conferences happening everywhere. I can set a reminder, for example, for JuliaCon, live demos. A reminder is set, and when I do Conrad Remind, it'll show me all the conferences I've set a reminder for. You can put that in your shell startup script. Every time you open a new shell, you see all the conferences that you're tracking. You can also look at conferences where the CFP is open still. So, like you said, submit a talk. You can also filter by location. And I think that's mostly it. There's different crawlers that I've configured. So right now, it scrapes all the Python conferences, all the PyCons, all the PyData conferences. But if you have other conferences that you'd like to track, submit a pull request with a crawler. It runs every Monday and Thursday at midnight, as you can see there, right on GitHub Actions. Yeah, I think that's mostly it. You can find the project on that link, or just go to conference-reader.readerdocs.io. Thank you.
Who's going? Going once. Go, there you are. All right, remind me your name? Thomas. Thomas! Oh, let's tell me. How are you trying to bring a laptop?
So, I don't even have any slides, so that's cool. I cannot fail with my slides. So I'm Thomas, and I'm from Graz, which is in Austria, in the southeast of Austria. And we just had Conrad. There is a conference in Graz in 13th of May called the Bar Camp. Anyone know what a bar camp is? Yeah, so few people do. So it's basically another confusing term, an unconference. So classic conference is like this: you submit your talk, and then it gets taken or not, and then you give your talk. And the bar camp, the schedule is generated in the first hour, and people propose talks, and then they decide when to do it. You get a room, you get a schedule, and people decide if they go to your talk or to some other talk. So basically it's very spontaneous, and it's basically every year in Graz. The basic topics, I think, still to be decided, but it's always something with software engineering. It's also with green technology, green energy. Typically there's a bit of usability, a bit of quality engineering, and also how this covers society. So like Mastodon is typically also something that is talked about there. And everybody can go there. You just need to sign up so they know how many people are coming, but it doesn't cost anything. And it's always a great thing to be there. You always meet interesting people, you learn something about new topics, and it's very easy to give a talk yourself. You don't even have to prepare slides or something. There's also just discussions as a format where you introduce a topic for 5 minutes and then discuss with other people who have interest about it. So very spontaneous, very flexible, and very fun. 13th of May in Graz, Bar Camp.
Does anybody want to accept a challenge? 240 seconds. Does anybody want to take a challenge? Going once. Going twice. All right, I told you I'd do it. Put 4 minutes on the clock. My name's James. I am a recovering whitewater rafting guide. That means I professionally took tourists down a class 3 or class 4 river. Right, thank you. The scale is 1 to 6. 1 is kind of your favorite lake. 6 is kind of like the worst water if I just don't. So class 4 is substantially dangerous. My problem was not the water. I'm a class 5 kayaker. I'm an expert. No worries. My problem was when you've been working the last 18 days and you're about to start your 4th trip, you are hungry. You are hungry, you are angry, you are sunburnt, you are sore, your body is screaming in a lot of ways, and you have to put on a nice customer face. Hey guys, welcome to the Dakota River. My name's James. I'll be your guide today. I am so excited to be doing this river for the 100th time this year. Right? And what does that have to do with software development? How many of you guys have been in a hackathon? Right? I did my first one in January, and it took me back because I wasn't just a rafting guide, I was a trip leader. That means I'm not just responsible for the 4, 5, 6, 7 people in my boat, I'm responsible for the other up to a dozen boats on my trip. I'm responsible for those guides. I have to deal with all of that stuff. They are also hangry. Guess what I brought to my first hackathon? A chocolate bar, exactly. When I was rafting, it was a muesli bar, granola bar, something like that, and a bottle of water. I kept it in my med kit because it was a lot more useful than anything else. Like occasionally you would need band-aids, plasters, you know? I gave out almost a granola bar, muesli bar every day. And so hackathon, yeah, because That's what we're doing. LLMs, they don't get hangry. Your people, I told one of the people on my team, you know what? Go take a walk. Take a walk right now. She said, we don't have time, man. This has to ship tomorrow. If you don't take a walk right now, you're just going to spiral. We got to go. Come on. Come back. Don't come back for at least 10, better 15 minutes. And she did. It was about 20. I was glad. Take that time. Settle down, right? This is what we are often not so great at in the software world. Dealing with this pressure, dealing with these other humans that are on our team. That is what being a trip leader in adventure tourism, when you have that hot sun and the dangers of the river, you know, those rafts go upside down sometimes. That stress, that pressure, being able to deal with that is great. You don't have to go start your whitewater rafting careers, but start thinking about, yeah, feeding your teammates, giving them water, bringing them coffee. I got brought coffee today during my talk. It was amazing. It was like, really, that was that whitewater trip leader in real life. And y'all, let's give coffee a round of applause. I also wanted to prepare slides for this, and I was going to do it tomorrow. Did it today. You guys, let's give all the lightning talkers one more round of applause. You guys are awesome. And one more round of applause for Ben, our timekeeper, even though we didn't use him that much. And one more round of applause for our technique and just the PyCon Orga team in general. Guys, this has been awesome. You guys are awesome. And speaking of the Orga team, they are giving me that look of like, yeah, it's 6 o'clock. Let's go to Mensa. Let's go drink beer, guys. Oh, you heard of that. Does anybody know about the special talk? Yeah. Is that you? Ah, that's the, you're doing
start. You want to introduce, give an introduction or whatever?
Yeah. Do you need?
Yeah, absolutely.
Yeah. And is there anybody here who does not know this guy yet? Yeah, I mean, he is everywhere, he has done everything, he is wonderful dinner conversation, everything from what is the history of learning and machines to, it was kayaking we talked about last year, right?
Last year, yes, absolutely.
Yeah, an accomplished flatwater kayaker, crazy waterfalls, but still really interesting stories, and quite an active collector. Big round of applause, guys.
We had a long conference, so right on the brink between the conference program and the evening program, I was asked to give a presentation of my collection of calculation machines. A particular feature of this collection is, do we find the here it is, that after the talk I will give you the opportunity to try them out. We have a lot of white gloves here, like mine, and I have those machines that are robust, and I can hand them to you that you can just try them out, and I think you will not easily find a museum where you can do that. But I think those machines live when they live, and living means that they're used, that they are calculated with, that a particular sound is also audible. And so, but as I'm presenting this for the first time in this format of conference, let me give you a brief talk about meaning of calculation machines, because it's something I think that's not so well known. Or do you all know about that? No, so I've already been introduced and I talk about mechanical calculators. So my personal story starts with my father taking me to his office as a, I don't know, 7-year-old, or maybe, no, it was early, I think it was still in kindergarten, when he brought me to his office, and his office looked about like that, because he was a constructionist, someone doing plans for steelwork, and he was working with a thing like that. I will explain it later. And about 4 engineers together had a machine like that one, and even the studied people had such a machine. I can show you live here. We have a projection. Minor technical problems, give me a moment. Perfect. A machine like this, so this is how my starter started, and when I later on get a chance to buy a couple of those machines for a cheap price, I don't know what was driving me to just do that. So this started, and then later on, the question arose, why did I actually do that? But the answer is, it's interesting that the first pocket calculators, look at the time scale, were coming out in the early 70s. And even a little before we had those table calculators. I have some in the collection, didn't bring them because it's not my focus today. And when you look up the big accomplishment of the Industrial Revolution, it was right before that, maybe 100 years before that. So the steam engine, the Eiffel Tower, the Ferris wheel in Vienna, or even just the Semmering Railway not far away from here. Look at the time numbers. So how did they do that? So I give some overview of the calculating machines, and I have some specialized lectures. Some of you have heard mine yesterday. But the hypothesis is, when you take a look at them, that an unseen revolution goes on before any industrial revolution, and that's the revolution of calculation. I think you can clearly correlate the development of the industry with the development of calculation power. I would like to see a statistic on how many divisions could mankind do per second with the technical artifacts that were built. So math is actually the game changer that changes the game before it's visible that it has been changed, I think. So, but you know the old Romans already did this, so even Caesar and Machiavelli said, divide et impera, so I translate this that those who can divide can conquer. And it's really the division that's the main art form among the four basic calculations. So how did we do that? In school we did this with simple aids. I brought some of them, like, you know, things like that. What is also interesting, stable books for the more stuff, where you can look up particular difficult calculations like sinus, cosinus, tangents, and logarithms and such stuff, which then looks like this. And then you can, for some system, which every book has different, look up what is the logarithm of I don't know what, or what is the sine of you know what, and the engineer offices had different levels of such books. So the good ones had 6 lines to 6 digits, and the simple ones only had 3 digits or so. So this is the table books. For school we have a nice gimmick, the educated monkey is it called. I'll show you that. So when you put this in here, you can do multiplication by adjusting the numbers below. Do you see it? Yeah, and when you move it, you get a different number. So 5 times 11 is obviously 55, or maybe 3 times 7 is 21, and so on.
7 by 8.
7 by 8 is 56. And you even have a square, so 6 squared is 36. So to right is the square. So it's the educated monkey. So these were the simple means, simple aids people could use before that. We even have those slide rules you might, some of you might still know from school. There are bigger ones like this one, or for more precision, but are actually based on the same system which I teach my students in math. So when you use that, you put the factor here, maybe it's you want to multiply by 5, and then you can read along any number, what is this multiplied by 5, so 15 multiplied by 5 is 13. At that time we didn't care for the comma. So you see, multiplication by 5, 1 multiplied by 5, so any number here is multiplied by 5. So sorry, it's the other way around, so I'm sorry about that. So this is 1, and now we multiply by 2. So 1.5 multiplied by 2 is 3, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, and so on and so on. And in the other direction you can do divisions. It's actually just a round form of the slide rule with some more precision to speak. So these were the simple aids for the simple engineers at that time. But soon they were able to mechanize computations really on the number crunching, not just estimating, because all those analogous computations is actually estimation from geometric facts, maybe taking into account what I teach my students to be isomorphism between numbers. So when you do logarithms, you just transfer the problem to a space where you can solve it geometrically. Very early starting, we have calculation machines of William Schickard, Blaise Pascal, and one of the first who really could do all the 4 basic calculations was Leibniz. But these were only single machines that were built, they were extremely expensive. It's interesting that then about the same discussion was going on and we have today with the AI. They were reasoning that when calculation is a mental process that's done by humans, how can machines calculate? That was the discussion. Okay, anyway, to bring this into broad use, some industrialization was necessary, and that started about in the 1870s, 1880s, when Oldner sold his patents to a company named Brunswiga, and that's many of the machines from these companies. So what is the principle? How does it work? What do you need for a full species machine? First of all, you need a counter. You need something that moves to the amount of digits you have. And there are two principles on that. The first one is the pinwheel. Maybe I show it in the image. It's a wheel that can vary the number of teeth that push out to the other one. I show you here in this example. This is one wheel that's put in this machine on that position actually. And let's try to show that. It's a little bit difficult to visit because there are some yellow wheels in the back. But when you really look at the black teeth, they get more or less popping out. Can you see that? And that's because on the other side of the wheel, they have such a strange slot that pushes in and out those slots, those teeth. So when you move this wheel along another tooth wheel, you get exactly that amount of steps that we pushed out. And that's why those machines look like that. It's actually to turn those tooth wheels to the right amount. So now I have 0 teeth, maybe now I have 9 teeth, and that's always the principle. There's another principle called the step wheel, the step roll, which I can demonstrate in one of the very old machines I have here, which I opened up for your convenience. Normally it's covered. And when you look into that, let's try it. Look here, you can relatively clearly view the step wheel. Is it visible? Yeah. Not entirely sharp. So this is turns when I do the addition. You see? And depending on where you move this little tooth wheel on the position it's stepping into the step wheel, it depends on how many movements it makes per derivation. You see? Now I have 7, so I move it where the step wheel has 7 teeth. And if I only want to have 3 of them, I move this wheel down, and now maybe it's 3. And now it's on the position where only 3 teeth are, you see, 1, 2, 3 are moving the wheel. You saw it? So this is the second principle. It's actually more robust. You can build it somehow smaller later on, but actually the pinwheel was more distributed. And there's even a swinging arm machine that's used for adders. Where do I have one? Here on this side. That's particularly fast. So this is just an adding machine. So this is adds 4 and this adds 9. It's just one extremely fast moving. Very easy to operate. So these machines were more used by clerks and business people, accountants or so. So they can actually, I think you can add up a large sum more fast than you can do in a modern finger calculator. So these were the principles. What else do you need? You need something to push over the carry from 9 to 0, and if you subtract from 0 to 9, so you have to change the next row. And that was a particular problem at first hand, because at first hand they did it directly with machines like that one for hand operations. And I can clearly show you the problem that was with that machines, because give it a look. This one is really from the earliest, I think it's about 1910. And yeah, you dial in here, it's also just an adder, you can just add. And the problem is, when you have 99 and you add 1, you actually have to move 2 wheels with only one movement. So this one affects that one, and this one affects that one. So the problem is, the more 9s you have, so now I have 9, 8, 9, let's add here 9, and here again 9. Now I have to move 1, 2, 3 wheels with only one movement. And so very soon this comes to its mechanical limit. So even the 6 ones won't really work. So we have to correct them by hand after that. So that's actually really the limit. But it's hard to show because it's in here. To put out a little lever and then distributing that movement. So it's here, this lever, that's responsible for the carry, more or less. I cannot go into the details, but you can conclude, even if you don't understand the details, that the carry mechanism is something very important for all those machines. So from the very early beginning on, you had these adders like that one, or maybe the Sabielny, which was very successful. You see the times for clerks. You can really hold that in hand. I think you can call them the pocket calculators of the past. So this one just works by pushing down numbers. So this, at that time, I just concluded a comma position, maybe it's here, so to add 1, it's to add 1, or it's to add 20, you take the next row and add 20. So 23, it's just like that. You could do it with a simple stick and read the result down here. So this is something you can really put in your pocket to do fast additions. So this principle applied all over the years because it was very easy to build. And particularly the machine was commonly used because it was something like that's what's given away like a pen. When you enter the engineer's office, you were given a ruler, a calculator, a pen, some paper, and then you should start work. And these calculators are therefore quite simple to operate. And I learned this very, very early because I also used them in my childhood. This one, for example, just has these rows here. This one is not correct. So it's brought to 0. And then you have the addition down here, the subtraction up here. And you just have to recognize that when you are in the red part of these rows, you have to go do the other direction. There is the real direction, so if I add 5, what's the problem with adding 5? Now I've added 5, I may add 80, now I'm 85. Now when I want to add maybe another 70, I'm obliged to move up and make it over carry. You see? So as long as I'm in the white part, it's fine to move down. When I'm in the red part, I move up and take it to the next digit. So the carry is actually that. Now I've seen this is empty, so I have another carry to make, which works like this. And you can imagine that these engineers were really putting this in their muscle memory, so it worked extremely fast. And this is just plain metal produced by the thousands, cheap metal. They were really popular and available until the 1970s because they cost about nothing. And yeah, there were machines for clerks and I don't know what. But when you want to do multiplication and division, you just have to add one feature, and that's the shifting. For multiplication, let's remember how we multiplied in school. We learned K by hand. Now, let's have some number here. Maybe we take 123, and we want to multiply it with something. So we actually have to add it several times. And we can count. Now obviously I've added it 4 times. But what we did in school, we shift the number and then we add it by the tens. So if we shift this here, we now add it 10 times every time. So we have it now 10 times, so in summary, to summarize, 14 times, 24 times, 34 times. And the same now goes to the hundreds. Another shift. Now I add it by the hundreds. So it's 134, 234, 334, and so on. So this number by this number multiplied gives the result here. And this is the principle that these machines had beginning from the 1880s to the 1970s. It was all the same. This is really one of my oldest machines from the, I don't know, maybe 1920s, can't say precisely, but even one of the latest machines, like this one here, have exactly the same, quite heavy, have exactly the same principle, although it already has a keyboard. It's still a mechanical machine. So I hope you can see it. I reset it here, and it's 1, 2, 3. And you see it goes a lot easier, but the principle is exactly the same.
And how often do you need to rotate it? Is this dependent on the...
It depends how much you want, or what you multiply with. So now we have multiplied 123 with 3,434.
Okay.
So whatever your multiplication you want to multiply, that many turns you have to take. And this is one of the last machines that was built in the 1970s, so to build a real keyboard into a purely mechanical machine was really an art form, I must say. I have to use this literally. But the most complicated thing was the division. How is the division made? Let's remember how we did divisions in school. We had to shift to the right position and ask ourselves, for this example, how often can we subtract 123 from 151? I have to estimate and then look for the rest. And that's exactly what is done here. With this machine, you start from the left. I'll show you the picture just in a moment. Is it visible? I think so. Yeah. So you have zeros here. It's a little bit. Now it's better visible. So I enter the, how is it called? Divisor. No, I can take this one. I have to go to lower row. Maybe like that. my 355.4. I set that one back to 0, and now I want to divide it by 113, which is my standard example, and now I push it in the other way to subtract and count the number of subtractions that can be done. And if it's done too often, I get a 9, and I will retract and try the same thing with the rest. That's too often, 99. Too often, and so on. Okay, you get it. Because I want to show you this with a little more modern machine, which was standard in the offices at that time, that had a decisive feature, which was the bell. I think I need that one. Let's put it here. I think that's easily visible, yes. And let's it's that one, 355. No, put the cable in here, please. So I have, no, not yet, I have to here. Have another. Okay. So I started 355 here, I have to reset that one. Now I want to divide by 113, and I just try it out. It goes 1 time, 2 times, 3 times, and then it's 1 too often. So I pull it back. 1 too often. And you even don't need to look. You can divide without looking. This is the division going on, and with the pump.
No, it's okay. I mean, even if you would make a mistake and you would have too much,
yeah,
it
even
would
if you
still work because it would have the Übertrag, so to say.
Yes, and if you turn too fast and make too fast too many, you can return them 2 times. You just have to watch for the bell. So the bell is in both directions. When the bell is run, you're right.
Yeah.
Okay, so this gave us a lot of famous and interesting machines starting. You see, that one was produced between, so in the 1920s. I have another one somewhere. No, that's downstairs in the museum, in the library, dating back to, I only know the production dates, I don't know the exact date when a certain machine is produced. We have that one we have already seen here from about that time. So this was an American model, very robust, very heavy, don't throw it on your feet. It was even produced with a number feet. Then we have a very old machine that combines the lever technique from these machines with the multiplication system here. So I just show it here, I don't want to carry it. So you can easily enter the number right here, which is a lot easier than such a machine, and then even just add. So this is the addition mode. It's just deletes the sum here after the addition. in multiplication mode, which is like this, it stays. Yeah, this is now, I think, multiplication mode. Multiplication mode is that, so then it stays such that you can multiply. But you hear the sound, I'm glad it's still working. It has an interesting mechanism to delete things, just pull the lever in different directions, and it does the deletion.
So for multiplication, you just add several times.
Yeah. And then in the 1930s, machines got even cheaper and simpler, and like when you look at that machine, you see it's industrialized. It's built in a lot cheaper way. It works exactly the same like the other machines, but it's made from, what's it called, blech? Can't read. It's just pressed steel, cheap pressed steel in big manufacturers. But it works the same way, like we have just seen, even with the comfort of being able to handle it with one hand. And you already seen the Brunswiger here, which are very heavy machines, which was not a disadvantage just because they lie a lot more stable on your desk, as long as they didn't fall on your foot. So yeah, let's go over that briefly. But there was two developments I want to emphasize in this talk. First one was the necessity. Yeah, you also have. I have a very nice Russian model. Even went to other cultures. It's working quite rough. But they were very robust and they were made in quite thousands. I was told that this is pronounced Felix. So you see, but it's exactly the same principle. The sound is a little rougher.
It's in Russian.
Ah, yeah, it sounds in Russian, I see.
Is there anyone which has a printing option?
Yes, there are many of them, but I explicitly don't collect them. Because they're hard to put back into operation, because they are clogged with color, and the color wheels are not easily to find, so I explicitly excluded this from my collection. And mostly they are also only with the salespeople. The engineers didn't need to print this out. But you're still interested? Won't I talk too long? Okay. First step was to make the machine smaller. So this is an interesting machine. It's a Brunswiger 10 because it was portable. It's definitely the machine of the German army in Second World War, because it could be put into a nice leather bag. So it was also a portable machine, and it had a slightly different mechanism. When you look into that, you're gonna see that it has actually a step wheel mechanism, but it was quite compact and relatively light. And this lightness enabled another development. I will come back later in my talk, because you saw the bell. So how would it be if we could combine the bell with a mechanism that shifts the lever by itself? And that was done first in a machine, in this machine. I hope I can operate it correctly, because it's very difficult to set it up live. Okay, let's see. We have 355 here, and we have to add it. No, this was the wrong one. No. and you see there's a more basic problem about that. And that's the problem. So, okay, yeah, and I have to have it like that. Now I can
subtracting 300.
Yeah. But actually, it should add.
If you turn it on the other.
But I don't find subtract. Add.
It has a little over 9 on them.
There's some hidden lever I don't find right now. You see, people they had a distinct course for learning their particular machine. So nobody ever had so many machines in their scope to learn to deal with. So that, now I got that. Okay. Yeah, okay, works. Yeah, that's it. Now, what it actually does is a division, and you will observe that it just moves when it's the last row. So actually this is just having the what we saw as the bell connected, directly connected. So I don't have to look at it, I just have to turn and so on. I think it's now finished. And here you have the result.
Can you see once more where the two numbers are? So the
two numbers are 355 and 113 because this gives a good approximation of pi. So this is my standard example I use all the time. So you can reach the approximation of pi.
But where's the second? So I see 113.
The first one is only visible at the beginning because it's subtracted from, and this is now the divisor 113.
The last digit should be a 7, isn't it?
Yeah, but this is an approximation by a rational number. So it's not precise, it's only 355 divided by 113, and you will know that pi is not a rational number. So it's just an approximation. Yeah, so this could then easily be put into an automatic, which brought up the mechanical machines, actually the cheaper mechanical machines. And this is definitely the successor of that one, because it was light and it was easy to build an engine into it, but it's purely electrical, meaning it only has a motor. And the motor is put on and off by a contact, so there's no electronics, it's really just electricity. So, let's turn it on. Okay, so when you divide that one, you just reset everything, and then it's semi-automatic. It does exactly that what we did before. Do I have this right? 3, 5. 5. Yes. Now I put it into division mode, and I have to reset the result up here. Now we can start division by subtracting 113 from 355, and often as it is possible while staying positive. So you see, semi-automatic.
When was this solved with the electricity? When was this solved?
The machine was built, you see, in the 1930s, and the other one was built 1960s. But it's when you say, okay, this was a clear successor of the mechanical ones, that's actually not really true, because the electrical machines that were quite older. But the problem was they were really totally expensive, which meant at least a year's income of a highly qualified engineer was spent on such a machine. And they were quite older actually. But at that time I have one machine that's where Institute of Astronomy of the University of so-and-so is written there. So you can imagine one professor with, say, 10 assistants had one such a machine together to do calculations on them, which in astronomy they obviously have a lot of that to do. I will try to show. Okay, you can see it. And then you have really direct dialing of the numbers. So if I want to make our famous division, I have to do it like that. It's 355 divided by 113, and you just and this was said to be extremely fast. How long does a division take in modern computers? So this was the fast one, a division by, say, 10 seconds or so. But still, you could do this easily by just dialing it in. And interestingly, those machines are just as old as the oldest one here, but the price was the problem. So this was even not affordable by an engineer's office or something like that. It was really like something a university bought for an institute or for the whole university or something like that. So I'm glad I have one that still works. Yeah, let's take that later on. Another topic was militarization, and I held a speech about that later yesterday. I cannot have the time to talk about that, but it is a really grueling and tremendous and interesting story for the Kurta, which was maybe the most interesting small machine. It's just hand operated, it looks like that, and that was the pocket calculator of that time. I just let you listen to the sound, because I think the sound impression of the machine is also extremely important. This was just how these additions in progress of the multiplications are done. I want to subtract.
You should know the sound.
Yeah.
Adding or.
Yeah, absolutely.
So does it do that division? Like, does it have a
Yeah.
or?
No, it doesn't have that.
So you need to just.
You need to watch. Yeah. It has a grueling story of a guy named Kurt Gerdstark, who, before he concluded this machine, was put to prison because he was Jewish, was put to prison in Buchenwald and was put out of the ordinary prisoners to build it, to keep on building the machine. So he continuously reported a little progress to sustain in the concentration camp, and he really survived it by that. Because he was promising he was built that for the Führer, and he really survived by that. Then he had to flee again, such that he was not put to the Soviet zone. It's a heartbreaking story, would be a talk by itself. Concerning the machines we have seen, it's always underestimated on how many there was. Just look at the numbers, like Facit, one of the most popular machine factories at that time, that produced really nice calculator machines like that one until the 1970s, had 8,000 employees in 100 countries, producing about 25,000 machines per year. So this was a really huge business. You had a shop in every corner, and it is only 15% of the market, so you can estimate on how many machines were produced and used. And I think this is the background of the Industrial Revolution that's often overlooked. So this was how such a manufacturing hall was looking like at that time. You see 1954.
Was it like one person working on an entire machine, or was
No, it was a production band, more or less. So I don't know the details, but anyway. So they built really robust, long-lasting machines at that time. So they really got into mass production, and you can use them so easily nowadays. The numbers are a little bit difficult to view here. Maybe if I could put it like that, but we already have a keyboard, and auto multiplication works exactly the same like we used it, but a lot smoother than we. And as you saw, I misused it a little. There's a lot of protection mechanism that doesn't let you press the wrong keys. And obviously, this was easy to mechanize, to electrify. This one is really a bomb. And the reason this is so heavy, because otherwise it was just jumped off your desk in movement. And to prohibit it from jumping around, it had to be built like a bomb, so such that never let that fall when you put it.
I have a question.
Yeah.
Why is the zero in the middle of the bottom row? It seems like a counterintuitive position.
I didn't get the question.
On the machine you just took away, the zero key is in the middle of the bottom row, so it's just like 1, 2.
It has another meaning, I think. You mean that one?
Yeah, that one.
Yeah. We're gonna have a look at the white machine afterwards. Maybe ask me a question in the private talks. I can look that up. But these machines kind of semi-automatically also could do divisions. So that's 25. Then you have put to the left, like with the other machine. Put it in the resistor up there. Then take 113, put it to the left. Choose the right operation, and then just press one button.
But here the zero is in the middle.
Pardon? Did I do something wrong? see this really hops off your desk if it's not heavy enough. But they're quite robust and commonly sold, as you see. You already saw them. The white one is actually one of the last ones where they try to fight off, they make the electronic calculators with the to no avail, because I will give another talk about the electrical ones maybe another time. But I was told that this is part of many interesting lectures about disruptions in economy. You have seen a couple of thousands of employees in really, really big companies, and as the electronic calculators came out, this industry, the whole industry, with its thousands of employees and specialized engineers and so on, you can imagine what specialization is needed to build such a capable machine after all those developments was gone in only 2-3 years or something like that.
Did the companies try to pivot? I mean,
yeah, this is actually an example of what they tried to do. They tried to make better machines and cheaper machines and everything, yeah? But to no avail. Such a calculator costed $25, and so such a machine still, with dumping prices and everything, costed a couple of $100. So it didn't make any sense, and it didn't work to fight the adopters. So this was maybe one of the biggest disruptions in industry in time, and it's commonly used as an example of economical changes, of fast economical changes in the past. Yeah. So this was my little talk and presentation. You can have other general questions to ask. Yeah.
Is there also original manuals you have?
Yeah, I have some of them.
Okay.
They look like that.
Oh, cool.
It's also interesting as I teach math on what language they use to express things. Because it's extremely, they don't use formulas, they describe by language, and it's from a modern point of view almost impossible to follow. So if you take the dividend by 3 and then add what? You read it 10 times before you start to understand it, if you have known it before. So really, because I have a special talk that I give you another time about how the square root can be calculated with such machines. I don't will present that today, and it took me almost a year to extract it from this manual. That's why they did courses. So it was a business to make teachers for those machines fly to Sweden to, for example, the Facet company. They had a separate teaching department where they taught the teachers that then were moved out to the various countries to teach the employees to use the machines. So when you were in an engineer's company, you learned in a seminar of about a week to operate your particular machine. And there was also a network of service companies. So in the cities, actually, on every corner there was a Büromaschinen, so office machine company that sold writing machines and calculator machines, which are kind of similar, and offered the service. So maybe every half a year, one of the people there came along with an oiling can and oiled and tested all the machines of an office, which was part of the normal operation. So you bought them actually with a service contract, so to say. Yeah. Now.